Hello. Shall I proceed? Hi, everyone. I'm Christian Langalis, aka Pindet Timot. If you don't know me, I run Terrell Corp along with Isaac, who should be seated in the audience there. Also with Logan, our other Terrell Corp co-founder from a while back. I'm sorry I couldn't be with you all this year. I had such a good time last year, but alas, my wife is due to give birth in 2 days. So couldn't exactly make the trip, but I'll be there next year, and I hope you all have a great time. So this talk is on making urbit real. And what does that mean? That I guess is why we're all here. You know, real is replacing the internet. Real is billions of urbit users and whatever, our future of comm computing to take over the world and leave everyone alone. So Terrell Corp founded with basically one core notion. You know, we're all urbit partisans and we all want to make it work. And we started with one simple idea, which is that urbit isn't real until you can make a living on it. And so that's just because markets basically reveal to us preferences. Markets show us that they show to us what we really desire, you know, what's worth our time, what's worth our money. So there's two sort of constituent parts of what making a living means. That's using urbit for work. That could be applications that don't have payments necessarily in them. And then it's also earning revenue in urbit native markets. And this notably excludes using urbit for fun, just as a hobbyist. You know, we're all sort of also urbit hobbyists. We're also all generally people who dog food urbit. That means we use the urbit software that we build for sort of non-real cases. You know, we're not exactly examples of actual urbit users because we're overly motivated to use it. So these two categories, using urbit for work and earning revenue in some urbit native market, these are distinct right now, but these will inevitably, hopefully, merge long term. So the basic market logic here is that urbit has to have a utility which exceeds the opportunity cost of usage. This is fairly just arithmetic. And primarily this means we have to overcome the drag of urbit as basically the slow, clunky MVP system that we've always basically known and it perhaps loved. So that means making it more efficient, which means lowering the time cost for people who are using it, making it more reliable, making it trustworthy that you could communicate with a client on urbit or somehow handle some business process that is critical with urbit. And then finally making it price competitive so that there's no what I would call an urbit premium, or you don't have to pay extra to use urbit. It's you know, it works at the same cost structure at the rest of the internet. So I take it that everyone basically can imagine, you know, building these urbit apps. And so far we've seen, so I don't want to sort of overly explain it, but this is basically what we've seen with urbit applications so far. So we have tons of toy apps, or what I call toy apps. This is how all urbit apps start. They do one thing. They just demonstrate the tech. They're basically hackathon projects, but they're not serious products. Then we take the toy and we refine it a bit, trying to turn it into a product. This could be, you know, trying to clone some existing product that already exists on the web, or even try to take Urbit's unique value proposition and, you know, sell something completely new. But so we basically rig up a product, but then it has several problems. It's too unreliable for business use. It's not cost competitive. There are lower friction alternatives. And as I mentioned before, all of the usage is actually just people dog fooding it. You know, it's just our, you know, the company, the several Urbit enthusiasts, and, you know, our mom, basically. So we are now trying, there's a few fake apps, as I call them, on Urbit now. And we're trying to turn them into what I call a real application, where usage is organic. Using the application is totally reliable for business purposes. There's de minimis friction to use the Urbit application over, say, an analog in Web 2. It's cost competitive. It doesn't cost extra to use it. And then one final point, which I think makes an application sort of de facto real, is that it has the capability of handling money. So I'll go into that in a minute. So going from fake apps, which basically look like real apps, but they just are too, you know, generally poor to use, to a real application, which is something that stands on its own 2 feet and is, you know, real, authentic Urbit usage. There's 2 primary processes, and both are sort of market related. One is just market feedback. So that's basically designing an application that you think could have product market fit, selling it, and then getting user feedback and polishing it, and doing that as a loop. And then the second one is sort of a shortcut, which is integrating payments into your application. And so if you have real world, quote unquote, people making payments through your Urbit app, you know, you can basically you basically are assured that you are over the line. You know, your application actually, you know, it does something real, whether or not it does it at a very small scale, but you're at least over the line of being real. So I'll turn the I'll put Studio, Terrell Corp's flagship app, in the hot seat here. This started as a toy. If you ever used it, it generates a web page from a group's notebook post. And then for the last several months to a year, it's been what I would call a fake app. You know, it has cloned some publishing features of other popular Web 2 apps, but obviously the usage is very low. It's all sort of Urbit hobbyists and early adopters. And so now we're in the process of turning this into something that has real commercial viability. We added payments, so it has ways for people to actually make money inside of Urbit. And, you know, we're also just rapidly expanding its features, automating things, and doing sort of a go-to-market strategy where we're onboarding a lot of people. So it now has at least the potential to be an Urbit native tool that people rely on for their daily business, that they could derive their livelihood from. So that Studio itself has a fairly Urbit native stack, which I think, you know, all Urbit apps or services will have some variation of these different components. So it starts with a hook. That's basically a way to recruit users from the external web. In our case, this is you know, a Studio native site. That is the like why we're starting with this publishing application. It's so that Urbit itself can go out to the external web and from a regular browser people can discover this urbit content, can consume this, can consume urbit blog posts, or in the future, podcasts or videos without actually having urbit. Then it has onboarding. You need to be able to actually draw people into urbit once you've put some information in front of them. So we have a hosting API that we use to basically give urbits to users. That's the second part of the stack. Then you need a way to distribute the app. So with our hosting API, we actually have the apps pre-installed. This might look differently if you're doing something else. But in our case, because we have the hosting API, we deliver the app from the get-go. And then we have a user database and a CRM, which is an agent that runs on Terrell. We built credit card payments, which are also a Terrell agent, so people can pay inside of this app. And then fulfillment, so actually, that's, I guess, the cycle repeating itself or concluding. It's an unending loop. That's actually delivering the content again. And so that's actually the ultimate point of the app, which is, the Studio itself just handles that. So I think that, I guess my message to, people who are either have an Urbit toy app, which they made in some hackathon or on their own, or are, trying to go to market with some Urbit product application, is, look at this stack and basically build in components of this so that you can basically go to market on sort of the external web at large. And so, as I mentioned, payments are really, I think, the litmus test for your success in that. If you can get people to actually swipe their credit card with an Urbit app or make a crypto payment, then you've done something right. And so you can actually then treat that as sort of the maximization function that basically, helps you refine what you're doing. It sort of quickens what you're doing. And I mean that in sort of the old English sense, which means, to breathe life into it. It basically is an organizing principle. So Terrell has worked mainly on payments over the years. We've been working with credit card payments. We have plans that we will be talking about at Assembly for general crypto payments. So here's a little matrix, and then we have a product, which is, of course, digital Urbit content. So far, this is a matrix of different payments, payment methods that exist on Urbit, and product categories that exist on Urbit. And green means that, to my knowledge, apologies if you belong on this chart and you're not in one of these green squares yet. That means that there is a live Urbit product that transacts one of these currencies or payment methods for one of those types of goods. So to run through them quickly, we have peer-to-peer Bitcoin payments. That's the Bitcoin wallet, which I created back at Tacen and is now run by the Urbit Foundation. I believe Holium has a Bitcoin and ETH wallet, also for peer-to-peer Urbit payments. Then you can also, I believe, with Holium and Portal, pay for digital content. So you can tip app developers, say, with Portal. You can also, the final green square is we have US dollars for digital content. So then these, on this matrix, the yellow squares, I haven't labeled them all, but these are areas that I believe urbit companies have intentions to go into. So, for example, vaporware is looking into ways of gating things with NFTs on urbit. I actually think Holium mentioned this in their talk yesterday. Gating urbit groups with NFTs. So the yellow are things that I think we could hope to see either later this year or in 2024. And then the blue squares, those are things that I don't believe anyone is exactly going for yet. Notably, real assets, purchasing a house or a car. These are applications that we would one day hope to see with urbit. I'd love an urbit stock portfolio, but that's sort of something to focus on at a later date. So we're all going for these yellow boxes right now. And so because this is a 4x5 matrix, so that's a lot of different ways to pay by a lot of different things that all have their own unique delivery mechanisms. So, delivering a digital urbit good, say group access or urbit content is that has different conditions than, say, delivering a physical product when the Mars Review of Books wants to deliver a physical magazine. That's a different intersection on this grid. So Terrell's latest project, which we are going to be discussing briefly now and much more at Assembly, is an urbit payment API. So we have basically a combinatorial explosion between these different payment methods and products, and we want to build an in-urbit API to basically standardize any payment method by any urbit native product. And so that is something that we very much are seeking your input on. So this is an invitation. Please join us for the Payment API Roundtable at Assembly. So I'll try to, I guess, in the spirit of just keeping it brief, I'll just conclude there. Say thank you to Jay and to Tacen. And if you have any questions, I'm happy to address those. Okay, so maybe no questions. Maybe that was all really
I've got a question.
and straightforward.
I have a question.
Oh, yeah.
It looked like on your list of your stack that you have a CRM database that maybe is running on Terrell. What does that look like at present? Is there plans for kind of expanding what a CRM on urbit could be, and how that might run for, people running Studio or other applications?
Let me see if I got the question right. You're talking about Ethereum payments for Studio content?
No, your CRM agent that you talked about.
Oh, this?
Yeah.
Yes. So this is basically a Terrell agent that we made. It sort of runs on Terrell, and it feeds data to the Studio app. This basically keeps track of who's made payments. Also things like, Studio has email delivery. So we, keep track of who has received an email if they subscribe to it.
Are there any thoughts you guys have about expanding that out so that, like what access does someone running the Studio site have to that data and manipulations around it and stuff like that for their portion of the customer base?
Good question. So right now we just tell you right now, Studio gives you a list of who your subscribers are. This is a very, I guess, crude or rudimentary CRM. You can see who's subscribed. You can see who's a paid customer. You can see when their last payment was, how much they're subscribed for. Obviously, in the future, this will be expanded for, say, who purchased your physical, good, who bought the T-shirt, who bought the magazine, who bought your merch. It's very much right now. Studio is sort of MVP on urbit native content, so these blog posts. But our goal is to expand the product categories, so go into physical goods, for example, and give users basically a basic e-commerce interface to be able to derive metrics from what their urbit native business looks like.
Very cool.
And
Thanks.
so this is more just this is a pattern that could be used for I guess any urbit application. You want to see who's using your app, who's doing certain types of activity, who's following your call to actions or something like that.
Any other questions? Okay, let's give it up for Christian, everybody.
Yeah, thanks. And you can all ask Isaac about this in particular. We definitely want to, especially on this API, we want to have your input. So we'll be setting a date for when that will be coming out shortly. So stay tuned and look forward to seeing you all in Lisbon for that. Yeah, thanks again, Jay and everyone at Tacen.
Test, 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 test. You got it? Good. All right.
Okay. All right. Thanks everyone for third day of fantastic event. I mean, we have such high quality people here. It's going to be great to see, like, even more orbiters and non-orbiters and people who are interested in it. So just in general, and more kids. That's a good thing to have. So what I have in my hands, it's going to be a raffle, as promised. So during lunch, as you pick up your lunch, please pick up a ticket, put some sort of identifier, Pappy, name, or whatever, and then just throw it in a tote bag that I'm gonna carry around, and we'll do 2 tickets. 2 lucky winners will win hats. Now, with hats, it's difficult to get the hats prepared beforehand because hat size, no one knows what their hat size is. So please figure that out. But what we'll do is, if you win, then we'll walk down to the hat store, and we'll get your hat, right fitted, and then I'll pay for it, and that's how you're gonna do it. Yeah. So yeah, please be sure to pick up a ticket, put yourself in there, and get it done. And also, during lunch, I'll do a couple tours of the building so that you can see sort of what we have here, and hopefully can lure some people into moving out here. That's my ultimate goal for this conference. All right. So, okay. What's next? Yeah.
Thank you, Jay. Okay, with that, let's get going on to our next talk. We have a Native Planet demo presented by Civil Hatred of Native Planet. Give it up, everybody.
Yeah, okay. All right, sorry, give me a sec. Oh, yes. There we go. All right, so hi everybody, I'm Civil Hatred. You might know me as Reed. And here I'm representing a company that me and 3 other guys have called Native Planet. And we make hardware and software for running urbits. There's 4 of us, and 2 of us are in Texas. The other guy in Texas, Dalhick Bandler, he started this project and brought the rest of us on. And he is the guy who builds all of the beautiful machines that you've bought from us in his garage like an elf. And Mopful Windrux, who you might know, is in Georgia. And Nalix Dosdrill is in Kuala Lumpur. We also have an industrial designer in Mexico who's responsible for those cool cases. And we do everything on Urbit. We run the company in a group chat. Hang on a sec. And we first started working together, the first 3 of us, last year in February or so. And then Nalix joined us about a year ago. And despite starting a hardware company in the middle of a chip shortage, we actually started shipping devices in May. So today my presentation is basically kind of a broad overview of what we do, and why we do it, and what we're hoping to do in the future, and what we've been doing since last year. So Reassembly is special for Native Planet because this is where we announced our project to the world. Those of you who were here last year, thank you for watching me present that and for presenting this. So we're the Urbit ecosystem's first hardware company, and we sell home servers that run in your house like an appliance, like a toaster. You can just plug it in and kind of ignore it. We have kind of a simple setup process that's sort of akin to a Chromecast, where you plug it in, connect to a Wi-Fi network, go through a simple couple of steps, and after that, it lets you boot chips like in a nice GUI menu. It connects them to the internet and makes them accessible, like from your phone or whatever. And we do this with software called GroundSeg, which is the software that we've written explicitly for running urbits. In technical terms, it's a purpose-built container orchestration system that we designed for running urbit. And the tagline that we have for it is that it's the best way to run an urbit chip. So all of the features that we developed for it are kind of towards that end. So we have stuff like just automated S3 hosting locally on device that's accessible on the internet with like one click. If we have the ability to control the device that GroundSeg is running on, importing and exporting peers, scheduling packet melds from outside of Urbit, and we have, obviously a nice GUI menu that kind of makes it a little more user-friendly for people who are new to Urbit, or people who just don't want to spend time in the command line. It's also open source, so you don't have to buy a device from us. You can just download it and install it on a spare PC. Sorry, I know there's not a picture here. I should probably just go back to the actual device. Let's see. So we also have an important feature integrated into GroundSeg called StarTram, which is what I spoke about at length last year. So this is the kind of custom networking backend that we built for GroundSeg, built on WireGuard. This is for forwarding your connection from your GroundSeg box to the internet. And on the other side of that connection, we have a reverse proxy that automatically configures, and it just serves your Urbit over TLS. That server also forwards AIMS packets back across the WireGuard tunnel. So it's basically like transporting your connection to this publicly accessible server while you retain the actual Urbit in your house. So GroundSeg makes running chips easy, and StarTram lets you access them from your phone while you're out of the house. And it's designed from the premise that setting up a command line app with a TLS reverse proxy and managing port forwarding is like a non-starter for pretty much everybody who's not already an IT professional or like very interested in this as a hobby. So there needs to be an easy way to do this stuff, and that's what we tried to do. We've reduced the complexity of this process to entering one password one time, and that's it. So we've created this stack for our devices to provide a technical solution to the problem of hosted versus self-hosted chips. Having a hosted chip is nice because you don't have to worry about running it or managing a process on a Linux server. But having a self-hosted chip is good because you get to control everything. You can possess data physically. So why can't you have both? And you can. So last year I mostly talked about the design of StarTram and the kind of overall value prop. And today I'm going to talk more about the big picture and how we see ourselves, along with what we've been working on since last year and where, towards what end. Oh, wait. All right. So in the year or so that we've all been working together, we've kind of developed a set of principles that act like a coordination mechanism for the design decisions that we make. This isn't explicated anywhere. This is just me kind of summarizing conversations that we've had in our calls every week, and what decision or what factors into the decisions that we make, and what are the things that are axiomatically good for us. So these are ideas that we think are cool, and we want the things that we make to be cool, so we want to use these ideas to shape the things. So this is kind of what I've arrived at as a summary. So obviously, all of us have a gut feeling that self-hosting is the right way to do stuff. So what's the point of having a personal server if you're running it on somebody else's computer? That means custody of your data, and on Urbit that means running your own peer. So our hardware is meant to be a home appliance for running peers. Our networking backend allows you to run it at home without sacrificing ease of access or worrying about your networking environment at home or how anything works. So all this is to say that your data belongs at your house, and we want to mitigate the complexity that introduces by solving the problems for you ahead of time. Ownership of your data needs to be as easy as any other option. We're also ideologically committed to open source software, and this is like table stakes for us. Everything we do is on our GitHub. It's permissively licensed. It's, I think, all MIT. And if I'm running a server at my house, it's not going to be a proprietary server. Especially if it's handling stuff like communication, I want to know what I'm running. I'll highlight that there's one exception here, which is our in-house managed version of StarTram. So we have an open source version of this that anybody can download and run on a VPS. They can look at the source code. The only distinction here is that the managed version, the version that we run, is like for running many instances or it's a multiple tenant instance basically. And the open source version is like for running yourself. But I mean, under the hood, they work the same and they have feature parity. So we're also open to feature suggestions and pull requests. And I think Little Wolfer so far is the only person who's taken us up on this. But if you have any good ideas, please let us know. Also, you probably will not be surprised to discover that a bunch of guys running an Urbit company are true believers. So we're Urbit maximalists. Urbit has a lot of rough edges that need to be smoothed out, though. So we see our role as edge smoothers in the service of onboarding. There's still a long way to go between now and Nox being the only legal form of computation, but we want to help figure out what gets it there, whether that's personal servers or some other value proposition that we all stumble upon. But I think it's clear that we have a dog in this fight and a predisposition toward the former. We also spend a lot of time talking about other ways to run Urbit. We've had a lot of conversations about what it would take to have first-class mobile Urbit, running it in other form factors, and especially IoT. And we have a lot of active lines of development, towards that last one especially, made possible by Lick, which I'll talk about a little bit, I'll talk about in a moment. And I would say the last principle is easy mode. It's the guiding principle of our design that we have kind of a default path that requires as little thought as possible. If you don't know how any of this stuff works, you should be able to basically just click next until it does work. So where complexity is unavoidable, we try to establish sane defaults and hide stuff in the advanced settings to avoid host scaring. If you have a problem with anything, our bug report button will usually get you the kind of customer service that doesn't scale and won't in the future. Under most circumstances, one or more of us will start looking at your issue as soon as it comes in. And at this point, we've resolved most of the major classes of bugs. So they don't really come in as much as they once did. So there's usually a single particular thing that people want out of running a ship, which is to turn it on and access it from anywhere on their phone or their browser, and basically forget about it after that. So we have sane defaults that are meant to minimize the friction for this path. As long as we're relying on S3 for external media storage, asking people to set up and configure it themselves will also be a tall order, since most normal humans have no idea what S3 is or why you would use it. To that point, most people never touch a command line in their life. And third-party hosting is the traditional answer to these questions of complexity, but we think that there is also another answer. All right, so this is our hardware. If you haven't seen it before, you'll notice that two of these are actually new, not for sale yet. The one in the middle is the Aurora, and the one on the left is the Tellurian 2, and the one on the right we call the Orbiter, which I'll speak about in a moment. So the Tellurian, which is not on this, but looks very much like the one on the left, was our first device. It has a custom aluminum enclosure with an exposed board and recycled PC components. It does a very good job of running like many ships. I mean, we've booted like 10 moons on one of them and didn't have any issues. We weren't like using them heavily or anything, but like they ran with like 8 gigs of memory. And they had 2 M2 NVMe drives and a hardware RAID 1 adapter. This was the solution that we came up with for like data integrity. It's kind of a hard problem because the peer is constantly appending and it's really, really big. So how do you make sure that you still have a copy of it? So we decided 2 hard drives is probably the way to do it. If you're familiar with the design firm Teenage Engineering, you can probably tell that we're also fans of them and we take inspiration from their visual style. And my favorite part though is that these have like a really thick chassis. Like they're heavy. The pictures don't do it justice, but if you pick it up, it's like 8 pounds. And it feels like a sculpture. So the Aurora, the one in the middle here, it's our premium device that we made in collaboration with Purism, which is a hardware company that focuses on privacy. They're American. So this is like, kind of like the Lambo to the Tellurian Civic. You can get it upgraded well, you can upgrade it a lot. The base model is very fast, but you can add on a lot more memory, disk space, and processor speed. I'm told that it also has an admirable heft, although I have not held it myself. But if there's one thing I'd like to impress upon you, it's that our hardware is extraordinarily dense and suitable for many self-defense purposes. So to elaborate on the car metaphor, we're also excited to release our tiny Japanese pickup, the Orbiter. Oh. So if you're in our public group, you might have seen some renders of this. We're trying to launch these at the end of the year. And you might notice, I guess it's hard on the TV, but they're very small. So these are x86-64 SoCs, but I mean they're like this big. They're like kind of like pie size, maybe a little bit bigger. And spec-wise, they're comparable to the original Tellurians, but with less memory. But importantly, they're much cheaper. They're like half the price of the Tellurian, and they're also like very light on power. So we haven't tried this yet, but you should be able to just like run it off of a USB power bank. So if anybody, I would encourage somebody to do that and to get like a USB LTE modem and try to like drive around and see if StarTram still works. So the neat part about shipping these is that like most of the work we do is transferable between devices. So, there's not a lot of difference between x64 boards and running on Linux, which handles a lot of abstracting away the differences. So we get to spend all of our effort on improving the software and making sure that the enclosures are charming. So we should have, I think, like a dozen of these to give away and at Assembly. So if you have a good idea for the hackathon, you might get one. And also, I mentioned they're called the Orbiter. All of us are kind of like not super into that name, so please come up with a better one and tell it to me. All right, our software that I mentioned, GroundSeg, is an urbit ship orchestration agent that has a lot of purpose-built bells and whistles for managing ships. And it's meant to run on a dedicated device, but it doesn't have to be one of ours. Our installation script should work on most Linux systems, assuming that I think you have to have like glibc 2.31 and systemd, which is like most Debian-derived systems. So we have like an install script on our website that you can just run, like paste into your command line because you trust us, and it'll download a binary and run it as root. And that's why we want you to run this on a dedicated device, because we have to manage the hardware. GroundSeg version 2, which you see here, is a major design overhaul. So we tried to take inspiration from Winamp 3 in the visual style. That was one of our points of reference. It's also got some changes under the hood in the back end that I guess version 1, the speed is not always what we wanted it to be, so we've redesigned how some of it works, and it should be a lot snappier, and it should be released around, or by assembly is what our deadline is. So I guess under the hood, the kind of main difference is that we're switching from kind of a conventional REST API to WebSockets, and it's a lot of other redesign stuff that facilitates the new interface. Nalex Dazril is our lead GroundSeg dev. That's the guy I mentioned in Kuala Lumpur, and he's been hacking away at this for the last few months. I'd like to give a shout out to him because he's a very talented developer. It's delivered a lot of wins for us in between teaching us cultural lessons about Southeast Asia. So probably the most exciting part of the V2 release is that we're planning to release a new urbit app alongside it. And internally, we call this GalSeg. Also a bad name. Please come up with a better one for us. We'll probably think of something before release. But since early on, we've wanted to be able to control GroundSeg from inside of urbit. There were various technical obstacles that made this harder than it sounds. But Mopful Winrux, the fellow in Georgia, has worked on a kernel vein called Lick that made this a lot more tractable. So the upshot of this is that soon we'll be able to control the host device from inside urbit, like through an app served through Urbit's web server, even remotely. So this gallseg app will allow you to boot and control other ships on your device from within your ship. So this also opens up the possibility of things like a self-hosted Lua equivalent. I should say this is opening the possibility. I'm not promising anything. One thing that is worth bearing in mind, though, is that you can control the device that your ship is running on, which I don't think anybody has done with Urbit before, which is pretty cool. I think you can actually manage the host. So this is an exciting frontier in Earth-Mars communication. This also is groundwork for deeper and perhaps device or peripheral specific integrations in the future. StarTram, like I mentioned earlier, is the networking backend. So this is mostly used for giving you a public web interface, but it also forwards AIMS packets, and it's kind of generalizable to just like network traffic of any kind. So we think of our boxes as home servers in the general sense. But our plans remain oriented around Urbit functionality, and right now we're working on home-hosted WebRTC using the same kind of backend as StarTram uses now, and it should be as easy as the S3 buckets. Although there's limitations. I think the main throttle would be like how much you can actually stream back to your home connection, right? So that might end up being the bottleneck. We've also started some tentative work on moving some of our CI/CD infrastructure into Urbit. This probably sounds more impressive than it actually is, but basically like GroundSeg checks a version server for just finding out what the current version of its components is and updating them if they're not current. And so what I'm trying to do is replace this just HTTP GET request for a JSON blob. I'd like it to be a remote scry, and whenever we push a release, I'd like to update the state of this of I guess probably a moon of our star, and then just have everyone's GroundSeg check that. I'm not sure if this is like realistic. It might DDoS it or something, but we'll see. So aesthetically, I think there's something to be said for trying to swallow what we can from Earth. This is very much to the point that Little Wolfer was making yesterday. We kind of have to accept the world as it is. A lot of the world is not pure Martian software, and we have to meet it somewhere in the middle. All right. So our CTO, Matful Winrux, has been busy contributing to Urbit core development. That's especially useful for us because he's had a close eye on new development and gives us time to prepare for changes or adapt to new features. But he's also a very skilled engineer, and he has a lot of feathers in his cap. One of those feathers is called Lick. This is, as I mentioned, this is a vein, a kernel module for hardware control from within Urbit. So this basically allows you to use Unix IPC, from Urbit, so you can communicate with stuff outside of your ship from inside of it. I think this is the first vein that was written by a non-core dev. This is for an Urbit Foundation grant, and it was completed, I think maybe like a month or two ago, and it should go out with the next binary release, which I think is in a week. You might have seen that he posted a demo on Twitter, which was him printing on a thermal printer from inside of his ship. It was, I think, a blimp down message. And he also took one of Mark's, Mark made a snake game, and he made an Earthside UI that was driven from Mars. So this suggests to me that maybe there's something with driving peripheral like displays or something that we could do here. Like I mentioned, it makes it possible for us to write Urbit software that crosses the hermetic seal and manages computers, or conventional computers. And this is the kind of thing that we want to do in the future. We want as many devices as possible to run Urbit, or at least be managed by devices that do. Matful has also been contributing to Lagoon and Saloon with Neil, and those are the libraries for linear algebra and matrix multiplication. So this is the groundwork for any future that Urbit has with machine learning. This is what it's going to be built on. So obviously we're also interested in accommodating that, although it's still very early days. And here's probably the most exciting thing I'm going to tell you today. This is the Reassembly 23 exclusive announcement. Those of you who know Motful Winrex probably know him as the guy behind the NOC-PU project. This is the first serious attempt to design a computer meant to execute the NOC ISA directly rather than virtualizing it, which is what we do when we run Vare. This is how I came to know who he was anyway, and this is why I wanted him on the Native Planet project. And our generous host, Jay of Tacen, has agreed to fund a research grant to complete the NOC-PU project. So this is a long-term project that is going to basically be his main focus until it is completed. So this is implementing NOC in Verilog and then programming an FPGA with it, which will be delivered on a little pillow to Jay, who will be the only person who owns one. And although he wants to impress upon, or Motful wants me to impress upon you that the end of this project is not a consumer product. This is a research project. This is as much to like do the thing as it is to figure out what problems there are with it and whether it's even worth pursuing, in the first place. It might turn out that an embedded interpreter is just inherently more efficient, and that at least this is why we're doing it, to find out what's possible and what we should be doing. So this kind of work is not easy. Motful has right now he has a day job. He in Native Planet work, and he contributes to Urbit Core. So it's been slow progress until now, but hopefully this will allow him to focus his efforts. And if anybody on the network is capable of doing this, then Motful is the guy. So I'm very excited about this. That's our stable diffusion mascot. That's Native Planet Chan.
So you talk about LIC, and then I saw one of your devices had USB ports. Mm-hmm. That excites me, and the way I get excited about Raspberry Pis what are the plans for the USB ports?
Well, so I should say, these are prefab x64 boards. We didn't put the USB ports there, but in the future we will definitely be aiming to take advantage of peripherals with LIC. That's the big reason that Motful did this.
Cool.
Do you guys have any plans for having Native Planets work at like a city scale mesh network?
So we have some tentative plans for daisy chaining on a LAN, which I think would be probably a similar kind of thing. And this has been a back burner item because it has mainly we started thinking about this because we were like, what if we had two of these on the same LAN and they have the same host name? How do we figure out if there's already one of these on the network, and what do we do if there is? And the solution we came up to is kind of like a daisy chaining thing where there's kind of a master server. But if anything like that comes out of what we do, I would think it would probably come from the development of that line of thought.
There's a question there.
I know you said that you're going to have some orbiters or whatever their future name is at Assembly for prizes. Uh-huh. Do you have like an estimate on like what you think the lower cost you might be able to hit is, and when you think they might be available for people to buy?
So our target sale time is I think December, and the price is I can't promise a number, but they told me that if somebody asked, I could say $250. Yeah.
Any other questions? I'm sorry.
Are you guys thinking of making one of these as small as the Urbit cube, or is that just not possible?
So the Urbit cube was I found the board that they used, and it was an embedded router, ARM board. It was. I guess it was technically capable of running Urbit, but I don't know if it would provide the experience that we. Maybe in the future, as things get faster and smaller, this will be possible. But at least what we're looking at now, I think probably the Orbiter is the smallest form factor we're going for, for the time being.
Okay. And another question: do you use LIC just for the hardware stuff, or do you use it for the hosting management stuff?
So I think we would be using it for the hosting management stuff. The CI/CD stuff I had mentioned earlier would be taking advantage of that.
Cool.
But this is also tentative. This isn't something that I have actually like finished or started using. So this is like just a thing I've been pursuing.
Okay.
So I very much agree with the ethos Native Planet has, that a personal device for your personal server. How is Native Planet thinking about things like small groups of people wanting to compute together, having like let's call it like a small family group where I'm the admin, right? I've got to coordinate all of these people together, and when something breaks, it's really my problem. But I need to be able to. How's Native Planet thinking about small hosting environments or boutique hosting environments?
So one of the things that we have kind of as a back burner item is kind of delegating a ship or a set of ships as kind of administrators that are able to manage this is really just kind of revoking permissions for other users. Like right now, if you have a user account on your Native Planet, you're the root controller of everything. But we would want to create kind of a tiered system where there's like users and administrators. And then once we have Gallseg, out there, and you can manage this remotely, it makes it much easier for like one person who's running a ship on a device to kind of manage the other people's ship, like their friendships, and boot them for their friends, and restart them or whatever.
Can you speak a little bit to the upgradability of your devices? Like if I buy one of your units right now, but I want to expand the hard drives later, for example, is that possible with all of these or some of these?
Yeah, okay, so I can say it's definitely possible with the Tellurian. I don't have direct experience with the Orbiter yet. I think there's like one demo unit that Austin has, Dalhig Bandler, and I'm pretty sure you can upgrade all of them, except I'm not positive about the Orbiter. But yeah, I mean they're not like they don't have like soldered memory or anything like that.
Okay. Any other questions? All right, then. Well, give it up for Sitful.
Thank you.
Thank you. Sorry. Okay, well, the lunch starts, so please enjoy and be sure to pick up the raffle ticket, and we'll work it out. Yep, thank you very much. All right.
You've been selected for this mission because you
Hey everyone, and welcome back from lunch. We are going to get ready for our second half of our program today with a presentation from Vaporware, Hardin Hardis. Everybody.
I get credit for the only animated slide, I think, right? Okay, so we're going to talk about how to build a ecosystem around free and open source software that we think can outcompete the advantages that Megacorp has. At the end of the day, like as great as a technical project as Urbit might be, that's only a single piece of the thing that we need to build here to bring about the kind of world that we want. The other pieces are around distribution and monetization. And we think that FOSS can actually play a key advantage in building an ecosystem that can beat these much better capitalized companies. So here's what I'm going to cover. I want to motivate the discussion a little bit, so provide some background. Part of our solution has to do with NFTs. So we think NFTs actually plug into a bunch of the gaps in the project so far. So I'll talk about what that looks like and why the NFTs are an attractive sort of primitive for this. I'll give a quick overview of how we're starting to build this out. And then I'm going to show our software and try and get all of you to buy it and use it with us. So that will come at the end. And I'm going to show pretty hard, so prepare yourselves. Okay, so why do we think that FOSS is actually important? What process is this playing into that can help us outcompete Megacorp? At the end of the day, product development is about the most iterations on software as you can get to increase your chance of finding something that's actually valuable and usable and technically feasible for your customers. FOSS is the fastest method that we know of for iterating on software design. Linus has this famous quote that with enough eyeballs, all bugs are shallow. This is not true in large companies where they build software hierarchically. It's certainly not true in the largest companies like Facebook and Google. The issue with FOSS today is that you can't actually distribute like open source applications easily with the source code. Even if you're selling an app that's open source, developers that want to build on top of it have to sort of like go out of band to find it in GitHub or some other repo and build from there. The bigger issue, though, is that there's no path to monetizing FOSS directly. You can sell apps that are FOSS on the App Store, but they're not these ecosystems, these distribution channels are sort of inherently in tension with the values of FOSS. So even though this has such clear competitive advantages from the perspective of a software development ecosystem, the channels of distribution and monetization that we have make this actually like not doable in practice. So this is part of what we're trying to fix with Vaporware, and what we think Urbit is going to be uniquely good at. Before I get to that, I want to go back in time though. I want to see what we can learn from ViaWeb. People that aren't familiar with ViaWeb, it's definitely got a claim for like the first great client-server web app ever made. Hotmail maybe can contest that a little bit, but this was early internet. This was also written entirely on Lisp, which is pretty fun and pretty interesting. This is like a DSL written on top of Lisp that the guys that designed ViaWeb put together so that their early users could design effectively like custom Shopify apps. You might not know what ViaWeb is, but you definitely know who Paul Graham is, the Y Combinator founder. ViaWeb is the thing that bootstrapped Y Combinator. It's the way that Paul Graham made his first millions and was able to then go on and fund startups. Paul Graham's best essay, in my estimation, is called The Other Road Ahead. And this is basically a first-hand account of the things that they saw at ViaWeb that led to web apps outcompeting desktop software, that led to, like, concretely ViaWeb outcompeting rivals, but more generally the ecosystem that was building around the early internet outcompeting a bunch of desktop applications. This is such a good essay that I'm actually going to read some of this for you. Paul's also a very concise writer, so I think this story will be interesting. Okay, this is Paul Graham now. At first, desktop computers didn't look like much of a threat. The first users were all hackers, or hobbyists as they were called then. They liked microcomputers because they were cheap. For the first time, you could have your own computer. The phrase personal computer is part of the language now, but when it was first used, it had a deliberately audacious sound, like the phrase personal satellite would today. Why did desktop computers take over? I think it was because they had better software, and I think the reason the microcomputer software was better was that it could be written by small companies. I don't think many people realize how fragile and tentative startups are at the earliest stage. Many startups begin almost by accident. A couple guys, either with day jobs or in school, writing a prototype of something that might, if it looks promising, turn into a company. And at this larval stage, any significant obstacle will stop the startup dead. Writing mainframe software required too much commitment up front. Development machines were expensive, and because the customers would be big companies, you needed an impressive-looking sales force to sell it to them. Starting a startup to write mainframe software would be a much more serious undertaking than just hacking something together on your Apple II in the evenings. And so you didn't get a lot of startups writing mainframe applications. The arrival of desktop computers inspired a lot of new software because writing applications for them seemed an attainable goal to larval startups. Development was cheap, and the customers would be individual people that you could reach through computer stores or even by mail order. The application that pushed desktop computers out into the mainstream was VisiCalc, the first spreadsheet. It was written by two guys working in an attic and yet did things no mainframe software could do. VisiCalc was such an advance in its time that people bought Apple IIs just to run it. And this was the beginning of a trend. Desktop computers won because startups wrote software for them. It looks as if server-based software will be good this time because startups will write it. Computers are so cheap now that you can get started, as we did, using desktop computers as a server. Inexpensive processors have eaten the workstation market and are most of the way through the server market. Yahoo servers, which deal with loads as high as any on the internet, all have the same inexpensive Intel processor that you have in your desktop machine. All you need to, and once you've written the software, all you need to sell it is a website. Nearly all of our users came direct to our site through word of mouth and references in the press. There is all the more reason for startups to write web-based software now, because writing desktop software has become a lot less fun. If you want to write desktop software, now you do it on Microsoft's terms, calling their APIs and working around their buggy OS. And if you manage to write something that takes off, you may find that you are merely doing market research for Microsoft. I think there's obviously a lot of parallels to where we find ourselves today. Oops. So, what lessons are there? Web apps won because they did things better for all three key stakeholders in the software development ecosystem. We heard from Paul how it improved developers' experiences, and a little bit about how it improved users' experiences, but it also made a huge change in the way that investors thought about investing in software companies. And this is a lesson that I think Urbit needs to take to heart and to design into the projects, the companies, the software itself. So developers, let's just recap here. Faster to launch, faster to get feedback, less wasted time. Again, iterations. This meant they could iterate faster. For any amount of money they were able to raise, they got more swings at bat. Bugs were reported faster. They were easier to locate because they weren't running in Michigan somewhere. They were on your servers. And they were easier to fix because you could launch an update immediately. And developers also had a global market available from them to them from day one. So it was easier to sell. You just had to stand up a website. You already had the server, just put it on the internet. And like Paul said, the users could come and find it quite easily. For investors, this is a great pitch. Team sizes are smaller. So for this same fund size, you can fuel many more bets. The web app model of revenue is also much more predictable than these big box releases that were happening for desktop software at the time. The revenue is predictable, and so if you were an investor with cash, you could go, you're in one market right now. If I give you an extra $10 million to launch 10 more markets, I know what the unit economics of that are going to look like. Finally, the fact that these startups had global distribution available immediately meant the ones that found product market fit could grow very quickly and could return the cash to the fund in a much shorter payback period than what the desktop companies were able to offer at the time. So investors loved investing in web app startups for this reason. Finally, for users, they got a whole bunch of new, absurdly cool applications. They could access their app state from anywhere in the world. Hotmail was one of the first large web apps that kicked off this race, because accessing your email from a public library or your mom's house was a game changer. It was much easier to find, try, and buy the software. You just had to find the website. Often they had some free version for you to test it first. And it was also much easier to run and maintain as a user. You didn't have to install it. There was no wizard setup. You didn't have to worry about sort of breaking changes occurring on your own machine. And then finally, the fact that these were all networked computers right from the beginning meant that you didn't just get better versions of what you had already. You got brand new kinds of web applications, brand new kinds of networked applications that had never existed before. And so users loved this too. Web apps won because they did things better for all three key stakeholders in this ecosystem. So summarizing, cheaper and easier development means more developers and startups get going in the first place. Because there's more developers and startups working on it, the risk is systematically lower for these startups. They get more swings at the bat individually. And it's systematically lower for investors because the same amount of cash for a web app funds many more bets than what they could have done for desktops. And because we're getting more guesses, because we're exploring the state space, this like possible set of things that we could be building for our users more quickly, users get better software from developers at a much faster rate than what was occurring in the land of desktop publishing. So this mechanism, this ecosystem, this set of designs kicked off one of the largest bubbles in history. It produced incredible software, it produced an absurd amount of speculative software, and eventually it popped. I think Urbit has to do better than this. I think our bubble needs to be way, way bigger. I think we can get there. The good news for us is there's weaknesses in the armor now. Software distribution has become locked down. You don't just need a website anymore. It's much more like publishing to desktop used to be than where web apps started. Monetization models are limited and prone to censorship. Go on Hacker News and see how many people are yelling about getting kicked off of Stripe for doing something entirely legal. That's not even looking at the worst offenders like Apple. There's actually now a huge development and maintenance burden that individual teams have to take on to release these apps because the stack has grown so sort of out of band with what they're actually trying to deliver to users. And apps have become corporate boring hellscapes because they've gotten siloed into just this local minima of what can be done with apps. Client-server architecture is limiting them in an important way. And actually the means of financing and monetizing these things are limiting current software companies in an important way. So what do we want? We want a system that makes software distribution uncensorable. We want a system that makes the monetization channels for selling that software uncensorable. We want to reduce the maintenance and development costs of the software to such a degree that small teams can once again launch meaningful, impactful products to users. And ideally, this system should create incentives for new kinds of applications to be built, not just rehashing the things that we currently have, but net new applications. Okay, so that's the motivating part of this discussion. That's like what has come before us. This is not a new challenge. Every revolution in computing has been marked by one of these turnings, where it's not just a change in software development and distribution, but it's a change in the channels that we use to sell the software and the mechanisms that we're using to monetize that software. So we think NFTs are sort of the missing piece to this. And I want to sketch out sort of broadly why we think that's the case. So again, these are the things that we want from our system. Some of these are already quite well fulfilled by Urbit itself. We have software distribution on a peer-to-peer basis. It can't be censored by any central body. And if you believe in the promise of Urbit and a very small, formerly frozen ISA, we should get reduced maintenance and development costs over time as well. But Urbit has no view on monetization today, no view on the channels or the incentives that we need to actually build these kinds of apps, not just technically, but economically. So that's where we think NFTs plug in. We think NFTs are sort of a primitive that we can use to monetize software built on Urbit. And we think FOSS combined with these three mechanisms, Urbit and NFTs, is the way to outcompete. So NFTs make software monetization channels uncensorable. On the left-hand side, you have some of the largest channels for distributing software today. They are all walled gardens. They all routinely censor, remove, or deny applications. On the right-hand side, you have an intensely competitive ecosystem of marketplaces, all pulling from the same universal database, where if you get censored as a token creator on one, there's 10 others that will list your tokens for you. And if there's actual demand for those tokens, you can be sure that eventually all of them are going to list it because these marketplaces are in a race to the bottom. That's why things like royalties have disappeared over time and why we consistently see platform fees for trading NFTs coming down over time. So on the left-hand side, walled garden, permissioned access. On the right-hand side, all the same benefits, global, but there's no setup. There's a inability to censor it. Okay. The other piece here, NFTs can create powerful autonomous incentive mechanisms. We don't just need a way of charging for the things, but we need to incentivize developers to build the kinds of applications that we think are going to be valuable. And ideally, we incentivize them to build in such a way that the design of the system actually outcompetes. Like the natural incentive is for there to be many more iterations of software development than what you see occurring in proprietary technology. Does anyone know what this image represents? This is the world's most valuable NFT release to date, as far as I am aware. This is Pox Merge, in less than 24 hours, POC sold over $91 million of NFTs. The NFTs themselves were just these individual circles. That's all the artwork was. The thing that people were speculating on was the clever financial mechanisms that POC had encoded into the smart contracts that basically governed the way that these things were distributed and sold and maintained over time. POC did something very clever. He said if you buy an NFT and then you get another one of these NFTs transferred into the same wallet, that new NFT is either going to merge into the existing one to make a slightly larger version of the NFT, or it's going to consume the smaller one that's currently in your wallet. So every time one of these NFTs enters a wallet, you take two NFTs and you merge them into one. And so the game is, can you get the biggest NFT? Or maybe you don't want the biggest NFT. Maybe you think everyone's going to be racing to get the biggest NFT, and actually having just a single unit, a single mass, will be valuable. Or maybe a community grows around these yellow ones, and that's the sweet spot. So this speculative financial instrument was itself enough to sell $91 million worth of digital goods. Imagine what happens if we attach working functional software to this. Okay, so those are some of the reasons why we think NFTs are the right primitive here. I've got quite a bit of material here. I'm going to try and give you a high-level overview of how we're building this, and then I'm going to demonstrate what this actually looks like in person. And you're going to buy it because I think you're getting excited about this. So we are turning Urbit's user space into NFTs. We are effectively, in a simple case, taking a Gall agent, associating it with a token on Ethereum, and then replicating the code of that Gall agent to the ships of anyone that buys the token. So in this setup, we have an azimuth point, which has a TBA. This stands for a token-bound account. This is a Ethereum smart contract wallet that is owned by the azimuth point. When you come along and buy the NFT that's associated with this Gall agent, what effectively happens on-chain is your azimuth point owns this token now. So looking at it from the ship's perspective, this almost looks like a module that you've installed into it, or like a license that's now on your ledger. So Vaporware is software running on Urbit nodes. It tracks contract item pairs. That's an Ethereum contract with the items coming out of it. We do desk and state replication on Mint or on transfer. And you basically have a software license for free open source software that is represented by an NFT that is owned by the token that represents the node running on the network. We don't just do desks, though. We just do desk now, but we're not just doing desks. We can do a desk, sets of desks, cards, paths. Land is kind of interesting. That's some earth creeping in. And all of this is distributed via a new namespace that Little Wolfer has been working on designing. He's called it Shrubbery Light a few times. I think that's not a bad mental model. So as we expand in sort of the functionality of this, you won't just be able to ship software, but you will be able to ship subscriptions, data, and earth content, whether that's a front end or images or videos, all encoded as a single NFT. And this operates autonomously once the users have the Vaporware protocol running on their ship. So this is an open question for us. And I thought this would be a little bit fun to run through and just like leave you with something to think about. But I want to sketch out what this could actually look like for development in a FOSS ecosystem. Let's say Fun builds a pretty cool app, and they call it V1. They turn it into an NFT, and they start selling it. It's popular, and so, of course, because it's popular, Fun wants to update it. They update it with some meaningful new set of functionality, and then they release a new NFT. For buyers that didn't previously have V1, they can just buy V1.1 and get the full thing. But if you were one of the loyal owners of V1, you get a discount on it. What's nice about NFTs is that all gets built in programmatically. They don't have to, the developer here, Fun, doesn't have to write this themselves. They get to piggyback off of all the degenerate DeFi mechanisms that have been made over the last 2 years to do this kind of stuff. Of course, if it's popular, you're going to have competition. So Neck comes along and makes Cold App to compete with Cool App. They think that there's actually a niche market in place where if you took the base cool app and made some changes to it, you could re-release it and sort of target a new set of developers. And of course, if this starts to take off, what you're actually going to find is that there's going to be many different versions of this. And over time, you would hope to see sort of a forking of base features coming with these apps, all built, again, off of Cool App v1. So this raises some interesting questions. If all these are NFTs, if each of these is monetized, what prevents fun from acting adversarially? Why wouldn't fun try and cut off or make changes continuously to v1.1 of their app to screw with Russ and Neck here? Did Neck and Russ have to go ask permission to guarantee like incentive alignment with fun? Do they have a contract with them? Should they pay fun pay upfront for the use of this app? What if they have not just Cool App built into this, but a bunch of other apps that they're pulling from as well? This is not a permissionless building ecosystem if you think about this from the lens of needing to contract with each of these developers. We think you can use NFTs to automatically remunerate all of the developers here. So if we say, Cool App v1 is selling for $10, Cool App v1.1 is selling for $15. If someone downloads Cold App v1, maybe they tack on an extra $5 of value there. So they're saying, I'll sell my Cold App v1 for $5. And as a new user, what you actually need to do is download the dependencies for that app as well. And what's nice about having these things represented as NFTs is you have a chain of dependencies there that are monetized that you can make an atomic purchase for. And so when a developer comes along and extends Cool App and sells it, the protocol that we're trying to develop, again, this is an open question for us, should automatically reward the more basic, more primitive apps that thing is built on top of. Part of the game, I think, for urbit software companies is going to be finding the most basic, the most primitive, the most universally desirable applications. Palfun, I think, has a good head start on this. Okay, so I'll leave off there. There's more to talk about there, and we're happy to show you sort of the functionality of this stuff in more detail. Now's the fun part. Now's the part where I get to shill the software that we've purchased. Okay. Oh, no sound.
Listen up, soldiers. You've been selected for this mission because you have...
Oops. No sound? Good? All right, well, I'm gonna move on then. We'll do the video in a few minutes here. Oh, actually, we need to transfer to my computer after that. Is this me now? It is. Okay. So this is the first piece of software that Vaporware is releasing as an NFT. This is live on mainnet. You can now buy this. Let me just try and play this through my speakers here.
Listen up.
Oh no! Now the Wi-Fi. It's not actually running on urbit. I'll let it buffer. Do I have to do the Steve Jobs where I ask everyone to turn off Wi-Fi? Please, we're struggling to give our demos.
You've been selected for this mission because you have what it takes to conquer the most formidable terrain on Mars. You have the skills, the courage, and the intelligence to overcome any obstacle or defeat any enemy. You are not here to play games. You are here to...
All right, well, that was pretty hype, so I'm going to buy one of these. Here's our mint page. 0.005 ETH. What an absolute steal. So let me go ahead and enter in my pat P here. Need to connect my wallet. And buy this now. I'll confirm. Okay, that was successful. I've now purchased this token. I'm going to get a DM in a few minutes from Ligbel, which is the ship that the star that we're distributing this from. It will include install instructions. We're working on automating this, but we wanted to get it out to you guys today. And let's just check Etherscan to make sure that this is real. There we go. Now, that's pretty cool. Here's the Tharsis token on my landscape grid. I'm going to keep calling it grid, Philip. I'm sorry. I pre-downloaded it so we could get some games going, actually. So let me open this up now. Here's the game. I don't have any games started yet. And I'm going to do something kind of interesting here. We bundle the client and the server code into this. So you can either play as a client, battle your friends, or if your friends are looking to battle each other, you can act as a server and host them. You can play yourself as well. So let me go ahead and set this up for us now. I'm going to set rounds to an hour. I will set max players to 10. I'm going to start a new game here. 0 minutes. Oh, thank you. So now I'm ready to invite some players. Let me just come back over here. Come back to this slide. We will invite the first 10 players that dot post in Ligbel/Vaporware that have bought and downloaded this game to play with us. So I have this live now, and I will see if there are any. Okay, we've got one. Oh, Sogrum is in now too. So let me go ahead and invite some of these people. I'll invite. We'll invite Sogrum as well. Sogrum double dot posted. If I start the game, Trent, can I keep inviting people, or will that? Okay, we'll leave it there then. We've got a bunch of information here on purchasing Tharsis. So if you'd like to review how to do that, you can join the group here. We've got a gameplay tutorial here, so you can understand basically how to play it. We've got some server hosting guide, and of course, this is free and open source software, so we have some developer documentation in case you want to try and hack the game, make a paint bot, or just spam people as you're playing. So this is documented and should give you a good head start on doing some fun things with it. That's our presentation.
When you launch the game, is it checking to see that you own the NFT, or
when you attempt to download the desk from Ligbel, it is pulling data from on-chain, seeing if the ship that is owned by the EOA that owns, checking to make sure that the EOA that owns the ship that's requesting it also owns the token, whitelisting you and then allowing you to download the desk from us.
What if someone downloads from somebody else? I'm guessing, is the check only on the service side?
Like someone else like republishes it.
Yeah, like I pull it from...
That's fine. Piracy is cool with us.
Okay, but it doesn't check the
It doesn't
NFT
check
ownership.
directly, no.
Okay.
Yep. We think there's other incentives to not pirate. For instance, if you got one of the first versions of it, maybe the developer is going to be providing some extra benefits to you, or you get into a private group chat where some real like Tharsis strats are being shared. So we don't actually think that you need real hardcore DRM to disincentivize piracy. It also just needs to be easy to buy, and that was like, I don't know, that seemed pretty easy to buy to me.
Any other questions? Okay, give it up for Hard and Hard As, everybody. While we get ready for our next speaker, Jay has some announcements, and we're going to do the raffle now. So,
all right. Who here? Okay. Who doesn't have ticket? This is last opportunity to. Okay. All right, everybody's got a ticket. No? Oh, come on. You're not cheating. No cheating. So hat draw from I don't know. I'm sorry. I'm kind of stupid. So I said hat draw out of a hat draw. That makes more sense. Okay, first winner is 990778. Ah, lucky man. All right, lucky man. Okay, all right, second draw. Okay, the ticket is 990755. Okay, I'll keep this in case someone wants to come. Wait, where? Oh, okay. Hey, okay. So that's he's a staff. So we'll do another round for the attendees. Okay. He'll get a hat too, but I hope it's not like 5 in a row of staff because I have to get them like 5 hats. Okay. All right. Sorry. I can't read. 990794. 99. Hey! Congratulations. All right. He can use it. He's in Texas, so he needs a hat. All right. Awesome. All right. Oh, you know what? Here, we'll do one more. Okay. I know. I am having too much fun. Okay. All right. One more chance. Whatever this is. 990791. Ah, there you go. Hey. What do you know? All right. Please come next year. You might win. You might win some hats. All right. Thank you. Oh, yeah. So, for those of you who are registered and watching us live stream, please respond to, I don't know, some sort of some tweet or respond to tweet, retweet, whatever, and say something that you knew that you learned about Urbit from like listening in to this conference, and then we'll do a draw from there too. So we'll send something nice, like like laser engraved something. I mean, we can't measure your headset, so that's the next best we can do. Anyways, yeah. So yeah, thank you. All right, next is.
Matt's getting mic'd up right now, so here you go.
Okay, so it's not a scam. So I actually have to take you to the hat shop. So we'll do that toward the end of the day. So because I can't just get you a hat, and there's no like a hat gift card. So all right, so we have to all right. Okay, thanks. Just get with me. Yeah, these are running.
Test. Good?
Okay, and we're back. Coming up next, we have a presentation called UIP 0103, Persistent Knock Caching, Adding Support for Persistent and Specialized Caching to SIG lists by Matt. Everyone give it up.
Do I have a clicker? Oh, okay. Thanks. Okay. Right. All right. Yeah. Well, thanks for coming. My name is Matt. Urbit ID's Master Bot Tech. Someday it'll be Mass Tire Bot Tech once we have enough. We actually have to pronounce them correctly. But, So yeah, this is like UIP 103. So raise your hand if you heard about UIPs. I like to call them whips. Okay, yeah. So like this is the new way to improve Urbit's core technology now. So actually, Native Planet already added the lick vein, which you heard about from Reed a little bit. So Mopful I think he's still putting together the whip for that one. But anyway, so this is the project I'm currently working on right now. I'm fairly excited about it. I was going to give a talk on like how to be a dummy and work on core technology at Urbit, but it's like I kept trying to hack it out. It just didn't fit. So I'm more interested in what I'm working on currently anyways. And I'm excited about this because I've learned a ton about Urbit along the way that had always just thought of sort of the black box part of Urbit. So yeah, so most of you heard about UIPs, but raise your hand if you've used SIG-less, this caching rune. Do we have a laser on here, by the way?
Yeah, the top button. It's so light though. It doesn't really show. Swing it this way.
Oh, I see. It doesn't show up on the screen.
Oh, sorry.
Right in your eye.
Yeah.
So I missed the hands. Who's used SIG-less? Okay, less so. Okay. Yeah, so sigless is a sig rune, so it's a hint rune, but we'll get into what it is and let's see here. Yeah, so pretty standard outline today. Give you a little bit of background on what sigless is as it currently exists, the motivation behind why we want to change it, upgrade it, delve into the design and implementation of the thing, and then wrap it all up and tell you what I just told you. So yeah, first thing is, pretty much I do have to give acknowledgments first off to Rob Nisserkfer, to Ted, because he's like I think he's the #1 spec machine in the urbit, which is appropriate given being the CTO of Urbit Foundation. But yeah, so I just try to pick this thing up. Like Joe has been wanting this technology that we're talking about for a long time, and then Paul Fid White Ragful, he helped me a lot with the implementation on the C side. But so those are the acknowledgments there. And yeah, let's go to the background. So sigless it's a very simple rune. It just takes some hoon. Okay, so P is like your hoon expression, technically called a hoon, I think still. So we're gonna take that and become this. Sigless of tomorrow. Okay. All right, well, what is sigless? I think this is actually the example from the docs. It's nothing too complicated. It's not the Ackermann function. It's a recursive Fibonacci gate to produce, the Fibonacci of A. So here at the top, we're providing the input 35 to our gate, which is A. And then we're branching on whether that is less than, we check our base case, right? I mean, everyone remembers Fibonacci, but if you try to do it on an interview, you might get hung up. I mean, I didn't. Maybe. Yeah, and so your branches, right? And if A's, I don't have to walk through it completely. I think you get the gist, but it's, it's going to nest a lot of core, and it's going to unfold a lot of buck calls, which are the recurs here. So without any sigless here, just the humble calculation of Fibonacci for 35 is like 16 seconds on my Apple Silicon chip. So pretty slow, not really too acceptable for what should be a mature technology. But you add a sigless to the top there, right before the what call, and you get 142,000 times boost in speed. Okay, so I didn't do that. That wasn't. I mean, I'll take credit if you want to give it to me, but no, I didn't do that. So this is good. So you're probably already starting to think. You can kind of maybe foreshadow what this thing does, but sigless is the cache of computation rune. Let's see. I think we.
Pointing towards the laptop
over here. Okay, right. No, we're good. Okay. Yeah, so I do want to explain this a little more though. Like, what exactly is it caching here is not really clear off the bat, right? It's like, how do you cache that whole what call, expression? It doesn't seem immediately obvious. So I guess the Hoon compiler is taking this and essentially rolling it out. So you're going to get not just one sigless call. You're going to get lots of them, for each value of A. So you're getting like Fibonacci of 1 and 2 and 3 and 5 and stuff, or even maybe there's a 4 in there. you're getting all of those inserted into a memoization cache, which is in memory. And so when you're going through it, when you know it's all like boiling back up in the recursion, you already have those values in the fast memory cache. And so it doesn't have to recompute anything, so it's extremely fast. Oops, okay. It actually works towards the TV too. And that's kind of like what I guess I just pulled that one from the Google, but that's pretty much what we're talking about. All right. All right, so what does the knock look like when we use zap-tiz to compile sigless? So it's a hint rune. So everything all the hint runes expand to a knock 11. And then after that, you just got like the term, a send memo, that is the hint type. And then after that's called the clue, which can be, here we're just producing, the constant 0. And then it's the formula you actually want to cache or retrieve. So we'll talk more about the clue later. But this is a dynamic hint. And that's because technically you can put a different clue in than the 1-0 formula. It'll become important later on. Hopefully I don't bore you to death. Yeah, this is fair warning. I should have given the fair warning earlier. We're going to get into some fairly, I'll keep it high level as, but. So sigless, it caches a subject formula as a key, and the value, the product, is the value in a essentially a hash map on the runtime side. Here's the caveat. And this is from the docs, right? And this is not like a bad thing, it's just the current state of sigless is these computations are only, they're transient to the current event. So if you wanted to hold on to, expensive computation and use it in a subsequent event, you can't do that right now. And so that brings us into the motivation of the upgrade. So transience is I guess, the biggest reason why the sigless needs to be improved. There's some user space things like, has anyone seen Landscape's mark warming thing? Yeah. So I think Peary and somebody else, maybe Jose, stumbled upon this a little while ago, submitted an issue to make Landscape a lot faster, because essentially the marks converting between some of the Hoon data types and JSON were not being cached. And so they were just really slow. It's like every time you wanted to do any sort of interaction in Landscape, it had to recompute. So yeah, the mark warmer was the way to work around that with the. Did they use sigless for that? I'm not sure. No, but they had mark warmer anyways. But I think the kernel space is the main motivation for this, because without the persistent caching, you incur a good amount of complexity and I guess I'll say lethargy. It's not a technical term, but not the best performance, right? So like the three categories I have here, Ames message deduplication, forward caching, and Arvo vein activation type checking. So I'll dive into one of those. Yeah, so like this is the opportunity though, right? Like there's a limitation with SIGLess as it currently is implemented, but adding sort of a persistence to SIGLess means we kind of get a thunk. Who's familiar with thunks? Okay, so yeah, I'm not super familiar myself, but as far as I've understood, thunks are common functional program, like other functional programming languages have these things called thunks, and what they are functions that take 0 arguments. And then you essentially wrap an expensive computation in a thunk and give it a symbol. And then the compiler sees that it's a thunk and can lazily evaluate it. So typically, I think in Haskell it means that it's only ever evaluated when it's needed. So you can pass it around without any extra computation costs to functions that want to use that computation. You see, with our SIGLess being persistent, they're not going to be lazy. The types of lazy thunks that don't clean their room or make their bed. We're going to have some industrious thunks. This may be, so because we're strictly evaluated in Hoon means that computation is going to be immediately evaluated, right? So not lazily, but we still hold on to it and can use it again and again when we want. So yeah, shoot. Laziness isn't generally good, and I think there's a broader discussion there. Technically and otherwise, I don't think there's no discussion otherwise, but yeah. Could go more into that if I have time at the end, because there was an interesting critique around this, being able to implement thunks in Hoon or not. But yeah, if you're interested in that discussion, definitely talk to me afterwards. So that's persistence. With the path parameter, remember the SIGLess P is a SIGLess and then a path P. This enables us to actually target a special cache if we want to. So if you want to use I don't know, if Ames wants a cat, or you want to prioritize certain computations over other ones, this opens the opportunity for that. Specialized caching, custom tuning. I asked that question, which other systems have this type of specialized caching, because I think it's kind of interesting. Obviously, caching exists in a lot of them, but being able to target caches, well, in functional language, I don't think they have that. I've never heard of it. Has anyone heard of specialized or like custom-tuned caches? Okay, Python has that?
Yeah, you do an annotation of null or you cache. I think that's
Okay, that's cool. But Python's not functional, so.
It's not functional and it's not persistent, so.
Yeah. I mean, you mentioned databases, like SQL databases, or maybe even NoSQL databases can like have custom-tuned queries, and they can even like, pick up on query patterns that repeat often and, tune themselves based on that. But I think it is fairly neat, something interesting or maybe novel in urbit. Yeah, so these typically complex systems can become stateless. The example I'll go into a little bit, which is actually included in the whip, is for Ford. Ford is I guess it's technically not its own vein anymore, right? It's in clay now. Used to be its own vein. And I looked back at the blog posts on urbit.org just to see, what's the history of the development of this thing been. In 2018, it was labyrinthine and poorly factored. I don't know who wrote that. That sounds like an insult, fighting words right there. But so in 2020, one of the well-known engineers proposed moving it into clay, and then so that simplified it, and that's kind of what we have today. But 2023, I'm hoping that it can be so simple it's trivial, and if it does become that way, anyways, is anyone familiar with the naming schema of the Ford so far? Like I guess the Skunk Works names for Fords. So like Ford started off as just Ford, and then it became well, there was an attempt that never got shipped called Ford Turbo. Okay, Ford Turbo. That didn't make it out, right?
It did.
Oh, it did. Okay. Oh, that's the labyrinth. Okay. Well, turbos do, right? On turbos, labyrinthing.
Yeah, I mean, it was actually a shortening of the Ford Turbo Encabulator.
Oh, not a turbocharger. Okay. And then Ford Fusion?
Yeah. And Fiesta was the one in between.
But there was a Fiesta? Okay, Fiesta? Fusion?
Yeah, there's also Ford Pinto in early 20s.
No, Ford Pinto. So, let's go Ford Lightning. That's what I want. Rest in peace, Paul Walker. All right, so yeah, design. This is like how it's proposed to work now. This is kind of, so a path is just a list of terms, I think. And so in this new design, if you just have the empty path, the FAS, it just goes into the transient cache, which is the same cache that we have today. With like a known path, like Ford or Ames or something that we implement later down the road to be known, that is it's targeting a persistent cache that's also specialized. And then anything else just goes in a persistent cache. All right, so this is the fun part. I was talking to Ted, and he's like, calm down. No one is born with an understanding of various bytecode interpreter. So this is the black box part. At least it was for me. Has anyone taken a look at knock.c in var? Okay, nice. Yeah, neither had I. I did glance at it, and this is the thing that actually makes knock run. So it's a very important part of the system. I guess, that's the lowest level of the system. That's like the heart of var. It's the connection between Unix and, Earth and Mars. And it's what's called a stack-based bytecode interpreter. So, I'll just try and get you up to speed with what I understand about it so far. This is the most exciting part, right? Because I figured I would never touch the the bytecode interpreter. Like, nobody touches the bytecode interpreter, you know? So here's what it does. Yeah, it compiles a list of ops. So these aren't the op codes in Knock, the 11 or 12, but it's like a list of 95 op codes that are used to tell for later execution. Okay, so those are the ops. You know, I imagine I didn't look at like the tokenization part and the parsing part of the Knock, but yeah, you know, chugs through the Knock that it gets and compiles a list of op codes. While it's doing that, whenever it sees a Knock 11, which is the hint, you know, Knock, it parses those in a special way, or I guess, yeah, special way, and it emits hint-specific ops to the list for those. And you know, obviously, we're working with send memo here, so that's kind of the area where we were working with. And then the next thing, it takes that list of ops and assembles what's called a bytecode program. And this is all happening on the loom. So it's pushing and popping things on and off of the loom stack. Which, for those not familiar, the loom is like the memory arena that Ver maps. The assembly part calculates the literals, the call and registration sites, the memo slots, and the actual bytes. And then finally, the burn step is executing the bytecode program. So skips through the bytecode. Actually, skips through is kind of an important point, like because certain ops that are emitted to this list, you don't actually want to evaluate, like for example, an if-else, depending on the truthiness of the condition, then you might want the if, you might want the else, right? So we have to know that ahead of time and be able to skip over one of them. Yeah, and then when it's executing, it jumps to those ops that have like computed go-tos. And so I've heard, I don't quite understand this part, but apparently the computed go-to pattern is a very common old school way of writing code, like with, I don't know, Forth, I think I've heard, is the example that I've heard. But it's the main reason why the bytecode interpreter is somewhat fast. And we didn't always have a bytecode interpreter, actually. Before that, we had like a naive tree-based interpreter. And so, yeah. So in order to enable the functionality of the new SIGLUS with the persistence and the specialization, I had to work on various parts of this knock.c. So like the way it works is, right, this is like a runtime feature. I mean, it's like something that Hoon requires, well, it doesn't require, right? It doesn't technically, because hints, right? Hints just say, hey, maybe you want to do something special with this. So the runtime, yeah, I already talked about the subject, like the subject's on top and then it does some computation and leaves a product. And then there's some like opcodes, which are fairly, well, they're actually, the names look worse on first glance than they are. Like the B, the suffix, the B, skib versus skis, slib versus sleaze, slies, I don't know. Maybe I don't know. They're, those are the opcodes that are responsible for actually looking up a key in our cache. And then the save one is for, obviously saving. So let's see if we could walk through. Like, think of the stack that we've got. It's technically not like a stack that just goes up and down because the way the loom is and the road model, it's like we're growing in and out, north and south roads. And the extra part of the persistent SIG-less is that when we get a cache miss, so a computation that hasn't been cached yet, we need to actually insert some extra information into that stack frame that tells us that we want to save this thing to the persistent cache if we have something other than an empty path like you saw in the design, right? And so just adding that little bit, just that one bit, you have to make sure that all the other parts of the interpreter that interact with the stack know that that thing is there, because this sort of stack context is crucially important for all these functions to work, because otherwise you might be looking at a piece of data that you expect to be this, but it's actually not. It's actually got this save bit on the front of it, and then it crashes everything, right? And then later, right, we use that bookkeeping information to see, okay, we're doing a cache save now, so is it going to be a persistent or a transient or a specialized cache? And then we can use that to do the correct hash map save. Okay, cool. Yeah, so that's all the pain I'll inflict on you today. Let's see. Yeah, so that's the gist of it, right? I'm almost done with the var side of this. So the runtime implements what we want for the most part, and what I have, I've tested it on all the veins so that I can use it, but I haven't actually upgraded the syntax for SIG-less, and in fact, it might actually become like a SIG-hep or some other rune, just for simplicity's sake, and we'll see about that. It may be a new rune, but it'll certainly be a Kelvin decrement for Hoon. And yeah, it was going to have persistent specialized caching. There's some waterfall performance gains we can get from this feature. I'm not sure how significant those will be, but I think fairly. Yeah, and then I omitted some discussion over NOC 12, which is the only virtual NOC opcode that we have, which is used for scry. But yeah, I'm happy to go into any sort of deeper on any of these things, but hopefully that was interesting and a little bit more of a window into what I guess I'll have to stop calling the black box. So yeah, thank you.
Do you have any questions? So if you don't make this a new rune, isn't it a breaking change? Wouldn't you have to specifically specify an empty path if you're just...
Yeah, exactly. So yeah, there were roughly 100 SIG-less calls, and it's just a find and replace out of the gates. And you think would we want SIG-less to be variadic, to take a variable number of children? Probably not, but yeah, you're right. If we do upgrade SIG-less, we've got to find and replace.
If we upgrade.
Yeah.
But also,
there's a way to do this in a backward compatible manner. Basically, it's we can go into the details, but yeah. So the SIG-less rune itself, yeah, we'll have to determine whether that takes zero, whether it takes just one parameter or whether we have it always take 2 parameters, and having it be variadic probably doesn't work. So we could add a second rune, as Matt mentioned, or we could just leave sigless as it is, don't touch it, and then if you want to use persistent caching, then you drop down to the lower level siggar raw hint syntax, which is what you saw in the example for forward there. And in that case, we don't have to change Hoon at all.
Can I put that back up? Now it'll be taken down for copyright violation. Where is that? Oh yeah, I guess I didn't include a cigar. Yeah, that's too. Did I?
It's in your trivial forward.
Yeah.
Oh. Okay, yeah, cool. Yeah, right there. Little. So that's how you can hint sort of directly. And all the other hint, what are the other runes that boil down to the siggar?
Any sig rune.
Any, yeah. Yeah, so all the hint runes boil down to siggar.
So one more question. As someone who's tried to figure out what the benefit of sigless is the primary use case in recursion, as your example was?
No, I don't think so. Just any expensive computation you want to hold on to and use again. Yeah.
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 Anybody else? First of all, this is sick. Second, yeah, I was wondering if you could talk about how this will impact everyday users and developers for builds.
For builds, well, it depends on somebody using it for forward to make a faster forward. So you want to do that?
I think it would be cool if someone
That'd be
did
cool,
that.
right? You have to call it forward lightning though.
Yes.
You mentioned that there's 3 kinds of paths you can use to annotate these siglesses. You have the transient ones as we have right now. Then you have dedicated, persistent specialized, and anything else. Is there a world here where the anything else also contains some information that lets you specify about, oh, I expect this to get hit very frequently for a short amount of time, or occasionally over a couple of days, something like that?
That seems like perhaps a future feature, right? Yeah.
Yeah, I actually think that's a good
That's
reason
cool.
not to make a Hoon rune for it just yet, right? Let the hint change shape, and then once we kind of have used this a few times and know, what it's going to look like, maybe we do want to add more metadata, then make it a rune.
Nice.
Yeah, I think somewhat along those lines. Are all of these caches going to live in the loom? Or are there any plans to kind of have something else, perhaps?
Yeah, so this is in the loom. Yeah.
I don't quite maybe I missed it, but what's the difference? But what do you mean by persistent, specialized, and persistent? I look at persistent if it, yeah.
Yeah, so persistent means that the computation will be cached across events. So yeah, until our cache reclamation policy evicts it.
Is the cache reclamation policy related to the path that you give it, or not?
No.
Okay.
I guess it could be. It could be someday. Yeah, it could be. You can imagine, all these the specialized features of this, like having a specialized backend cache. This is just the opportunity that's open now with this work. So somebody somebody wants to work on the Ford. And all right, we're going to use this, and not only we're going to use persistent caching, but we also want a Ford-specific cache that has some special logic for tuning or reclamation. So those would just be PRs, you know.
Okay, yeah, I see. I guess I misread the middle part as like one long path, but you're saying there's one, there's two, and there's many others. Those are the specialized ones.
Yeah.
Anything else? Okay, that makes sense.
And we haven't defined any of the specialized ones yet, right?
Right.
But they could be Ames, Arvo, etc.
Cool.
Yeah, just to give a little example of why you might want specialized caching and not just throw everything into the same big cache. So you want Ford caches to behave differently from Ames packetization caches, for example. So Ford build cache, you're caching the compiler and the parser, the Hoon compiler, Hoon parser. Each time you run that, it takes a long time. You want those caches to stick around for a very long time because you actually only do a Ford build every once in a while. And so you actually, you want it to persist for a long time if you can. Ames packet caches, what those are for is for, well, there are a couple different ones, but we can talk about the Ames serialization cache, which is what could replace there's a manual deduplication logic in Ames right now that does at least linear traversal of every outstanding message that you're trying to send, so it's pretty slow. But we need to do that to make sure that the memory doesn't get duplicated so it doesn't use too much memory. And so so for that cache, you don't necessarily need that to hang around for that long. But you might have a lot of them, a lot of cache entries, right? So you might want to say like, yeah, this cache can get really big, but actually don't hold on to them for that long. Each entry tends not to be as large as a Ford cache entry. And then we may also add another cache for Ames that's for caching packetization, so taking one slice of that packet and encrypting it, sticking a packet header on it. And in that case, you want that to be a very short-lived cache. You don't need very many of them because it's mostly just going to get used a couple times. And so, right, so each one of these you want to have like few different kind of knobs that you can turn to tune to optimize each cache.
So this question will pull us a little bit out of the depth of the caching, but this is UIP 103. Do you have any kind of reflections on the UIP process so far, or how's that experience been?
It's pretty good. So there are a number of UIPs that definitely recommend checking them out. Like for Joe's talk yesterday, there are 2 whips with that. Yeah, I think it's good. I mean, it's not overly formalized. It's not like an RFC. Someday you won't be able to go talk without having a corresponding whip. Maybe. But I think I guess the highest friction part has been like writing a whip after the fact. Like after it's all done, it's like somebody has to go back and actually make sure that the document reflects, the implementation, and that's kind of a pain. I think that's happened in a number of cases. Like lick is now being written as a whip after well, it's just about merged. And then, yeah, at least a few times now. So, yeah, it's not perfect, but I think it's good because it's like, this is open. It's a urbit/UIPs with an S. So, anybody can visit, take a look, submit a PR to improve a whip that exists already or submit a new one. And, there's like a process that goes through. This is probably a different talk, but yeah, it's good. It's good. Works.
Any other questions? No other questions? Okay, let's give it up for Matt, everybody.
No, thanks. Thanks.
we're back. Welcome back to Reassembly, guys. This is the third day, and we are winding down. We're getting ready to watch our next presentation, which is a portal demo from Toptic Builder. Round of applause, everybody.
Thank you, thank you. I'm Top Tier Builder, Brady. I'm the founder and CEO of Portal, which is bringing sovereign social media to the Urbit network. So let's start with showing you a little bit about what Portal is. So if you could switch to my screen. So Portal is social media on Urbit. It's native to Urbit. You can write posts in a very familiar way. You can reply to other people's posts. You can leave likes and comments, and all the standard features that you would expect to find in a social media site. On the right, we have a recommended sidebar, which shows you sort of a live pulse, an ability to discover what's hot in the feed and what's being recommended at the moment, whether that's groups or other ships or apps that you can find, all native to Urbit. And I see Doppler Harbor chiming in here as we speak, so love to see that. Similarly, we've really taken links to flex the composability of Urbit inside of Portal. So on the right, you can see we have composability with radio, which is basically allows you to do live streams and group in a Twitch-style format, gathering around a single video. So you can see all the live streams happening, Reassembly being the most popular one at the moment, and you can jump right in straight from Portal. Similarly, we've taken composability very seriously in importing your pal's social graph. So you can jump right in, you have context, you can find all your friends very easily, and you're able to reduce the friction of moving between different apps. So if we jump in and we select a profile here, this is Warp It Build It. This is our, our company ship. You can see we have a variety of different collections that we've put together. So whether it's apps or groups or links online, you can throw them and organize them and do what you want with them. So if we jump here, we can actually view the Portal app. And Portal also supports App Store functionality. So you can see, of course, Portal has a 5-star average review inside of Portal. It wouldn't happen any other way. But you can leave a review of the apps that you've used. And you can even charge payments for your apps and gate downloads all on ETH. So and even reach out to the developer if you so choose. So full functionality for being able to use Portal as an app store. Similarly, even more posts. Similarly, we can jump in. Seth, do you have your ETH address uploaded by chance? Uploaded. Tough. Well, there goes your potential tip that we could give you. But released earlier this week, you can now tip anyone in Portal that uploads their ETH address. So Badass Tacen here is one of the longtime users of Portal. So we'll jump in if it loads, and we can leave him a tip. I swear this worked 20 minutes ago.
Demo curse.
Say again?
Demo curse.
Yeah, demo curse. There it is. So we can give him a tip, a measly 0.001 tip. Sign into MetaMask and send him a tip, completely peer-to-peer over ETH. Ta-da. Yeah. So you can now become your own digital patron saint and shape the media and the content that you want to see in your own image, all in a peer-to-peer fashion. So that's a little bit of what Portal's about, and you can switch back to the slides at this point. Thank you. So in building out this social media experience, we butted up against a lot of the same problems that, that you guys are probably quite familiar with. So primarily, we've all experienced this, right? You're up at 2 a.m., you're doom scrolling, you've been sucked into the current thing on Twitter, whether it's LK99 or some culture wars BS, or you've told Twitter for the 1,000th time, I'm not interested in this tweet, don't show me this, mute, on and on and on. Yet the next week it pops back up in your feed, and you're back on the hedonic treadmill yet again. So we all have like visceral experiences of the problems with particularly ad revenue models taking us for a ride. You don't control the algorithm. And so what Portal is aiming to do is, in the same way that user-generated content transformed the content that we consume online, we think Portal and Urbit and decentralized networks offer the opportunity to let user-generated algorithms transform the way that we consume content. So with that in mind, let's double-click on these bad incentives. So ad revenue models, obviously bad. And a byproduct of this is that the algorithms are built for advertisers. They're not built for you. And so it's like a direct opposition in the alignment that you're actually looking for in your social media experience. And taking this to the extreme, this means advertisers can throw their weight around, leading to deplatforming and censorship, which we're all too familiar with, watching on crypto Twitter over the past couple of years. So these are bad. You can't control your feed. That's the bottom line. And this isn't a novel insight. There are a variety of other tools in the Web3 ecosystem that have recognized this problem and are looking to solve it. Unfortunately, the promises that these Web3 social networks promise are hardly being lived up to. And this is for a variety of reasons, but namely the real data ownership that they purport to provide to you is somewhat of a farce. With any of these networks, you are still at the behest of a fairly tight cluster of basically nodes that are indexing all of the content and thus generating the algorithms. And the icing on a cake is if you want to develop your own feed algorithm, you have to be a machine learning engineer to make anything compelling. And this is just a non-starter in terms of really democratizing and offering an efficient marketplace for all the types of experiences that you can have with this content. So how do we solve this? What's missing? So first and foremost, we attack the accessibility of generation of these feed algorithms. And like any good Web3 startup over the past 12 months, we took a good hard look at this and we decided to pivot to AI. So frictionless algorithm generation using the magic of LLMs is one component of the puzzle here. The second is real, tangible, and functional data ownership and freedom of exit using the Urbit network. So instead of like the friction of like trying to migrate your feed from one node of Mastodon to another, you can actually tangibly do this in Urbit today, and not only like have your own data, but have it in a context where you can manipulate it, compose it with other apps, and do really interesting things with it. And so then and only then are you able to achieve the vision of this flourishing marketplace of custom feeds. And then you have this Cambrian explosion of modes and forms in which we consume content that we're so excited to see coming. So let's see, I'm not sure if it's time for this one. Yeah, you can switch over to my demo. So let me show you how we are implementing all of these silver bullets. So we're releasing just today. Is someone? Yes, get your 5 minutes of fame. So at the top here, you can see a feature that we just released this morning. And this is a ChatGPT API-powered feed algorithm. So let's say I jump into Portal today, and I'm looking for some joy and positivity. So we'll basically take the corpus of Portal posts. Keep in mind, these live on individual ships, but they're collated into your browser in a peer-to-peer method. We send that to the OpenAI API with the prompt, and lo and behold, we get back a different vibe that's characterizing our feed. So we have a recommendation for a group that's purporting to reclaim our humanity, or talking about how to have more fun based on the questions you ask, or a YouTube channel that someone loves. What's the most beautiful thing you've ever created? I love Brady from Yuri. Even Kenny chiming in, glad to be home. Well, that's nice, Kenny, but maybe I've had enough of Kenny today. And I want to say, yeah, let's just mute that guy. And in the same way you can dictate things you want to see more of, you can dictate things you want to see less of. And so we've muted sick dev Pilnup, and down we scroll, and there he's gone. Ah, much better. No longer have to listen to Kenny anymore. Similarly, we can say maybe we want to see more about tech or programming or what have you, and characterize our feed in that direction. And the feed will morph into be talking more about Hoon or Hoon School Live or rubber duck debugging in order to give you the experience that you're really looking for. So this is all well and good, and this is interesting kind of semantic search that we basically implemented here. But and you can imagine sort of extrapolating this and having more of a dialogue with your feed algorithm. So as you go and you discover more and more constraints that you want to apply, you can tell it, and then it can update for the future. Not updating on your revealed preference, but rather your explicit stated preference before you've been limbically hijacked. So all that's really cool. But what's even cooler is sort of extrapolating what's really possible when you have access, an AI that has access to the content in such a way. I think the form and the modality of content consumption can actually be changed, as well as the style of content that you're looking at. And so I think Elon and his experiments in Twitter are exhibiting this really well. So you remove the 140 character limit from Twitter, and suddenly you're competing with Substack. You remove the 5-minute video upload limitation, suddenly you're competing with YouTube. You dictate that I only want to see images from friends that I know in real life, suddenly you have an Instagram clone. All of these are possible, dictating it simply to an LLM that has access to all of this data. So as some rudimentary examples, we can say, let's look at just links. And we can turn Portal into a link aggregator for a bird's eye view of all the links that are passing through. Similarly, we can say, only show me long form posts, looking at the word count that exists in each post. And now the posts don't get too long inside of Portal just yet, but you can see we can trade out the fast-paced microblogging experience for a more calm blog browsing experience. And so taking this to an even further extreme, you could imagine turning Portal into an audio-native experience, as if you could drop in deepfake voices for every person, and then basically turn every thread into a mini podcast. So you can transform Portal into this audio-native, hands-free, eyes-free, more calm experience. Or even more pie in the sky, you can imagine speaking to your personal LLM and just saying, hey, tell me the news today. What's happening? What do you think I should know about? And the LLM would be able to infer from the context that it has of you and your interests, what's most important to you, and then deliver it to you as a friend would over a coffee. So this is the really exciting vision of where you can go with this technology. So we're very excited to basically build the thing that builds the thing, and allow people to choose their own destiny in terms of how and what they want to consume content-wise. And you can switch back to the slides now. So what's the big deal? Again, large-scale experimentation in how we consume content. And not only that, but giving that power to the users themselves. So in the same way that user-generated content made it such that you can be the change that you want to see in the world. You can generate the content that is missing that you can't find enough of. In that same way, a user who is the closest person to the needs and the problems that they're experiencing can develop their own algorithm. And then you can really address the long tail of needs throughout people that want different types of experiences in their social media. And again, leveraging Urbit to achieve that real sovereignty and real freedom of exit that they can use leveraging Urbit's infrastructure. So this begs the question, why are we building on Urbit? And so as we extrapolate like the size and the volume of data that's coming through these algorithms, we quickly realized that we would need basically indexer nodes to be able to cut down on latency and offer performance benefits. Urbit provides a nice substrate and an existing infrastructure to spin up these infrastructure nodes and to be able to incentivize a federated network that offers censorship resistance and takes the power out of our hands to be able to like censor or do any dictation of what is proper speech on the platform. So to really achieve like true decentralization, Urbit provides a wonderful like bedrock to build upon. Not only that, but composability with other apps. The functionality of pretty much every social media app ends with that app. In Urbit, it is much, much easier to extend that functionality far beyond what the limitations of the devs of that team are. So this is evidenced by the PALS integration that we have, as well as being able to import your blog posts automatically, or the radio implementation. So you can, like, using building blocks, plug and play different functionality across the ecosystem. Not only this, but you can imagine trading in your self-hosted Uniswap front end that Larix Wolder has put together, and being able to live tweet your trading as you go straight to Portal. And so these sorts of composability and like pipelines are much, much easier in an Urbit context. You could also imagine you're drafting your latest blog posts in Holium's Ngram, and you can publish to Portal button and just like send it directly to the public square without needing to worry about custom integrations or data sharing and anything like that. And so finally, the long-term vision here is that the centralization around the user offers unique advantages for personalized AI in Urbit. One frame that was really useful for me in grokking Urbit was that Web 2 and SaaS centralizes data around the company. But on Urbit, and with any personal server technology, you're able to centralize the data around the user for the very first time. So the data network effects and the composability that was largely reserved for monopolies like Apple or Google is now available to every Hoon developer. And this presents like really, really fascinating opportunities for being able to bring as much data into Urbit as possible and then recontextualize it for other purposes. So to make this more concrete, you imagine all the data that you're generating in Twitter right now, your likes, your engagement, the way you speak, what you speak about, what enrages you, what makes you laugh. All of this data could be yours that you could use to then personalize your own AI. So if you're using a digital assistant LLM in Urbit and you would like to have it coordinate comms for you, maybe you could take your work group chat, have it summarize it every week, and then publish it to Portal as an investor update or as marketing copy. You could similarly have a personal assistant that's able to dictate comms for you, handle meetings, set up all these things. And because it has the context of your calendar and your interests and your docs, then it's able to make really, really intelligent decisions on your behalf. So this is really exciting opportunities to take personalized LLMs to the next level inside of Urbit in a privacy-preserving way. So what's next for us? Clearly, the demo we showed today was a little bit bare bones. We've got a long way to go to make this a really compelling feed algorithm that you're going to come back to and is going to be engaging enough yet freeing enough for you to really enjoy the experience of. Saving and sharing feeds, again, is a critical part of this. So you can jump into your friends' feeds and put on your goggles, the rose-colored goggles of your pals every now and then. Groups aggregation to be able to seed Portal with much more data so that those algorithms are actually being put to good use. a Web2 mirror so that people outside of Urbit can see all the lovely schizo posting that we have going on in here and get sucked in that way. And then finally, support for local LLMs, so we can achieve some of that grander vision that we laid out earlier. So we hope you'll join us in letting 1,000 algos bloom. Thank you.
Regarding the Ethereum tipping, when you do that, does that put anything in like in a feed that somebody could see that a tip was sent? Either on like maybe a post that you wanted to tip for, or just like as like a feed entry or something like that?
You mean like, do we broadcast the fact that you made the tip?
Yeah. I think that would be a cool thing to have.
Yeah,
potentially.
We've mocked that up.
Yeah, okay.
Of course, to flex how much commerce is flowing through Portal. But yeah, and like a counter showing how much someone has earned on Portal, either by selling apps or by posting blogs or what have you. Those are all on the roadmap.
Cool. Thanks.
Yeah.
So what's Portal's business model?
So this is a tough question. Obviously, a lot of the selling point in Urbit is hosting is a surefire way to capture some of the value on the network. This is an option for us. That's not like our edge really, so we haven't been focusing on that. Basically, like a way around the bad incentives of ad revenue models is having this fixed cost. So you can earn the same amount basically through subscription fees, right? And you can decouple the fact that engagement time is generally proportional to ad revenue for a company. So subscription revenue for creators or people generating feeds, that way they are incentivized to build and maintain high quality feeds for people, and then potentially taking a cut of that. There's, tokenization is another route to be able to remain credibly neutral and not tax along the way and still promote early adoption and growth of the network. And yeah, as much as we hate on ads, ads have done wonders for the free distribution of information on the internet, and ads are also another way to attack this problem. And notably, when you have freedom of exit and you can voluntarily choose another feed, the ad incentive issue becomes much less prevalent. So.
Is the data for tipping available to these algorithms?
No. So all the algo gets is like at this point in time, it's the name, the date, and the content of the post.
So is it possible to have Web2 feeds as well? And in terms of feeds, is there like a toolbox for third parties to make new feeds, or do you make all the feeds yourself?
So currently, there's no saved feeds. You show up and you create your own feed right there if you don't like the default chronological feed. Obviously, this is going to change in the future. But the intent is for anyone to jump in and be able to generate their own feed using a rule set that they provide to AI. I think your previous question was Web2 integrations.
Yeah.
We've been experimenting with Farcaster and Blue Sky. The integration overhead is quite high for bringing that into an Urbit context. So we're leaning away from that at the moment. But of course, we're keeping an open mind. Yeah, currently it's going to be Urbit native.
Okay. So for instance, I'd like to be able to include like newsletter feeds, email newsletters, things like that.
Sure. With our given roadmap of groups aggregation, you could pipe that into a group potentially, and then use that to accomplish what you're looking to do without any special help from us. But yeah, all interesting opportunities. Mm-hmm. It's just so much easier to remain in an Urbit context.
Yes. So Portal is one of those Urbit, at least in an Urbit context, an example of an app that has only been around for a couple months, but has already seen a lot of integrated iterations in terms of the UI, the user experience, a lot of active users. Just wondering if you have any general tips for other small dev teams, and so far as lessons you've learned, whether it's being disciplined with releases, getting updates out, listening to user feedback. How do you juggle it all?
Totally. That's a great question. So one thing that is a pain point that we all know is like breaking changes coming through the kernel or from the UF. The UF has made strides recently to loop in app developers into that process and basically prove out big changes with the developers that depend on them before they happen. So I would definitely lean on strong, tight communication with them so that you have heads up as things are changing. I think some of the best product advice that I've heard about Urbit was a talk given by AJ Lyrics-Wolder during Dev Week a couple of months ago. And he basically said too many people in Urbit are trying to build the blank of Urbit. And the fault in that strategy is that one, these are more unoriginal ideas that aren't really differentiated from their Web 2 counterparts. But two, they're not leveraging Urbit in a unique way. If you're building on Urbit, for all the difficulties and the friction of learning a new stack and all the effort it takes to get spun up on Urbit, you should be building on Urbit because it allows you to do something you can't do anywhere else. And so that's probably the biggest and most critical piece of advice that I would echo.
Thank you.
Any other questions? No? All right, let's give it up for Top Tier Builder, everybody.
Thank you, guys.
Okay, thank you. Thanks everyone. So next speaker is Ted. Needs no introduction, but I'm just so glad that so many people from the core team and beyond, app developers and venture capitalists and everybody else joined. And so this is like my dream come true, to bring all the friends together and have a lot of fun and talk about tech. So just wanted to kind of give thanks to Steph, who's without whose help, very difficult put this together without, and Virgil, who's also been supporting, yeah, and video folks at DGW Video, yeah. Yeah, definitely go check out their website, dgwvideo.com. And we make website too, so go ahead and check out Tacen.com at some point. And yeah, Steph, you want to take it away?
Alrighty, so we're getting into our very last presentation of the day. Again, thank you everybody for your undivided attention for the last 3 days and for everybody online who's joining us in the live stream. Without further introduction, we're gonna learn how to get to Kelvin Zero, which I'm sure a lot of you guys are interested in the Urbit community. Ted Blackman, everybody.
All right, how about now? Yeah, okay. All right. Thank you. And before I start, I'd like to just say that I'm very grateful to Tacen for hosting Urbit here this week. This has been an incredible conference for me, and I think for a lot of other people. So let's all give a round of applause to Jay. Thank you very much. So my name is Ted Blackman, also known as Ravnus Rickfer, and I'm the CTO of the Urbit Foundation. And I've been working on Urbit not as long as a few people, but for about 6 years now in various capacities. And so I'd like to think I've learned a few things about how to build Urbit. And I'm going to talk today about what I've learned, what kind of principles you can use, or what kind of principles we can use at least, to try to make our own software timeless. Maybe some of that is interesting for other people here as well. And I'll talk about our core development roadmap. So where we are, where we're going, very rough timelines on some of these things. All right, let's get into it. How to get to Kelvin Zero. So there's a long quote about how to do this. I'll read it. The dream of absolute zero is an operating system whose core components are so simple, so boring, and so mechanically straightforward that we can imagine them becoming finished and never changing. We need to freeze not just a format or a protocol, but a language, a kernel, and a standard library. To succeed, we need to flush out each quirk, complexity, and creeping feature until the system is so boring and obvious that no one even wants to change it. As you may be aware, not all of Urbit has met this criteria. In fact, there are some, so there are some parts of it that have, or close to it. I'll go through these. I actually like, people usually talk about the lowest layer of Urbit as being knock, or machine code, but I like to think of the lowest layer as actually nouns. That's the data structure that everything in Urbit is built out of, right? So it's a natural number, right? Either 0, 1, 2, 3, or bigger, or it's a pair of nouns, what we call a cell. So it's either an atom or a cell, so it forms a tree where the bottom of the tree is all numbers that can be arbitrarily big. Everything in Urbit is built out of this data structure, including knock or machine code. So we don't have a Kelvin version on nouns, but we're not going to change them. Next layer up, and we usually talk about this as the lowest layer of the system, is knock. Knock is at Kelvin number 4. So we could change it 4 more times if we wanted to. My personal guess is that there's about a 50-50 chance that we'll ever get to knock 3. The chance that we get to knock 2 is very low. We don't have any plans for knock 3. Knock seems fine. That's my take. I think there's pretty broad agreement on that among the core devs. We have a lot of problems, but knock ain't one. The next one here is Arvo as being close. I skipped Hoon. So Hoon is their programming language. And actually, I skipped it on this list because there are a bunch of things that I'd like to change about Hoon. There are things that are not good about Hoon. There are problems. There are improvements that we want to make. Quite a number of them. But Hoon is serviceable, actually, right? Like whenever I think about what's blocking us being able to do something in core or even in user space, the Hoon language is rarely the thing that's the blocker. So it has warts, it has problems, but you can work around those problems in just about all the cases that we've encountered, at least for its stated purpose as a systems programming language. Right? So it's statically typed, it's concrete, it's low level. It kind of feels like writing C, but it does what it's supposed to do pretty decently. So Hoon is close. It's close to being close to freezable. Arvo, the kernel proper, is actually quite close to being frozen. So when we talk about the urbit operating system, Arvo can mean 2 different things. It can either mean all of kernel space, right? So like all of the whole operating system, including the kernel proper and the kernel modules, but it's also the name, somewhat confusingly, of the kernel proper, right? So the structure of Arvo is that it has something vaguely akin to a microkernel, and that it runs a number of kernel modules called vanes. And those vanes mostly need a lot of work. But the kernel proper itself is actually quite close to being frozen, in my opinion. There's one big change that we want to make. That's a proposal by Philip for breadth first move ordering, when we're also going to pin the scry handler. If you don't know what that means, don't worry about it. So there's one change. It's a fairly small code change, fairly large conceptual change. But the rest of Arvo, I wouldn't change anything, really. So that's actually a pretty decent place to be, right? Like of all the things that urbit's trying to do, our machine code and our kernel are pretty close to where we want to be, where we want them to be. So that's a nice base to build on. So you can see the history of urbit here, where knock was developed first, Hoon was developed on top of that, Arvo was developed on top of that, the vanes are developed on top of that, and then user space, right? And so the oldest parts of the system have had more time to get all the kinks worked out, and they're a bit more stable. So it's not really surprising, but you do see it when you kind of think about this. There are also, I've listed 3 vanes here, Dill, Ford, and JL. Well, Ford used to be a vane, but 3 kernel space modules that I think are close to being Kelvin versioned, or Kelvin versionable, meaning close to being freezable, really. The first is Dill, so that deals with terminal input and output. So command line, you're typing in to a terminal and you're seeing text come out on the screen. Dill handles that inside of urbit, and I think Dill is really close. Now, if you ask Palfun, who wrote the last version of Dill, there's all kinds of stuff that he wants to do to it. But honestly, I think it's fine. The same sort of happened. The same applies to Ford, I think, where like I wrote the last version of Ford, mostly, and I think there's a lot that I'd like to do with it, but honestly, it's fine. If gun to our head, we have to freeze Dill and Ford, okay, not that bad. Similarly, jail. So jail is the module in urbit. It's a kernel module. It's a vane, and it handles the PKI management. So, I have a key, public-private key pair associated with my urbit address. You also have one. In order for me to send a message to you, I need to know what your key is, right? And so we look that up from the blockchain. We have an Ethereum layer 1, layer 2. That filters through some applications. There are bugs actually in those applications. They're a little frightening sometimes. but we can generally recover from them at the moment. But some known issues there. But jail itself, after it hears some information that's been filtered by those apps, I think is actually in a very kind of freezable, timeless state, because its conception of the public key infrastructure is that it doesn't have anything to do with Ethereum, right? It's just, hey, there's some source of public key information, and there are some things that that has to have Byzantine fault-tolerant consensus. But no matter what that is, that could be some other blockchain. If somebody builds something else that's not a blockchain but somehow better than a blockchain that still implements BFT, then jail would still work with that. We would switch to a different app, different pipeline for getting the data. And that's actually a really good sign, right? That jail itself wouldn't have to change in that situation. So that's one of the ways we know that jail is pretty close to timeless. Now the actual code itself, we could probably quibble. I don't know if I would, love for that actual code to be what lasts for thousands of years, but it's serviceable, right? These things are serviceable. That's what I'm getting at. So these are the parts of the system that they're not bad. You're like, all right, we can work with this. Then there's the other parts of the system. These do not spark joy. This is not a complete list. Yeah, I'm not going to read them. Suffice to say, we have a fair amount of work to do. But we have learned a number of things from getting even those parts of the system that aren't done yet, things like clay and gall that, that have warts in them that are major warts that we need to fix. Even for those things, we've learned a lot about, believe it or not, a lot of them are a lot better than they used to be. I think Philip probably knows that more than anybody. How long have you been working on Urbit now?
It's very close to 10 years.
Yeah. Would you agree that some of these things are better than they used to be? Okay. So here's some principles that I kind of cobbled together here. So when I think about taking any module within Urbit, or Urbit itself, or a subsystem within Urbit, or protocol, some piece of it, and thinking, okay, how can we make this timeless? These are some of the ways I think about that. So I will go through these one by one. The first one is what we call solid state. Right, so this goes back to the beginnings of Urbit. The idea is NOC is a solid state interpreter. So this is an analogy to hardware, where in contrast to a hard disk drive that has a spinning disk and a head that moves back and forth, a solid state drive has no moving parts. So this is why you can drop your laptop and it's okay. 15 years ago, if you dropped your laptop, it was not okay, because the hard drive would bust. So that's an analogy, right? But solid-state electronics have major advantages. No moving parts means harder to break, last longer, etc. So what does that mean in software? What does it mean to have no moving parts? Well, and it means a few things. It's a little vague, but you feel it when you're working on Urbit. Urbit is more solid-state than the vast majority of systems, and we're trying to build a solid-state world for software. Solid-state interpreter with NOC, where the interpreter itself is stateless, right? It just takes in a NOC expression and runs it. And then the system gives it another NOC expression and it runs that. And the way it does that is deterministic, pure functional, right? So there are no hidden inputs. There's no kind of there are no little weird dongly bits that are hovering around that affect the computation, right? And much of software is plagued by weird dongly bits. So this is a little vague, but this is probably the number one thing to think about when thinking about, can we Kelvin version this? Can we freeze it? Is it timeless? Is it solid state? And we're trying to extend this notion up into user space with solid state subscriptions. What makes those solid state is that they're backed by Urbit's immutable Scry namespace. So the data, meaning the inputs to any calculation, those all have immutable names and they have provenance, right? But it's a solid foundation. You're having code that operates on a solid foundation, and that's a form of being solid state. The second principle is rage-driven development. If you look at a piece of code in urbit and it makes you very angry, you probably need to fix it. Now, this depends on who you are. If you're just someone on Hacker News, I don't want to hear about it. But if you've spent some time looking at the system, right, and you know kind of why it is the way it is, how it got that way, what problems it's solving, how much worse it could be, and you still have that feeling, that's a good signal, right? This is a way of reading from your intuition and saying, okay, this is bothering me for a reason. I don't know, maybe it's just that I'm getting old. All I can do now is my intuition. And the third, which is similar, is grug. So grug is a sort of hypothetical caveman. And he's not maybe very sophisticated in our modern ways, but he knows what's important. Right? So grug say, grug wants solid state subscriptions. Grug want put movie into urbit. So when you're thinking about this, like, how does grug feel about it? We need to please grug. It's very important, right? This actually goes back to the first quote, right? Like, it has to be simple and obvious, right? And it can be challenging, actually, to keep grug in mind. We have to, things can get sort of heady sometimes. So this is a good check. All right, now we'll get into some more technical ones. One of the big things we've learned is to remove asynchronicity whenever possible. So, and this is asynchronicity defined pretty broadly here. It can mean a number of different things. But what I mean by it is that, let's say I'm a piece of code I'm running, right? I'm running some instructions one after the other, and then I have to stop and emit a request to some other module, some other machine, something else. And then I have to sit around and wait for some response to come back. And then when the response comes back, then I'll pick up again. All right, so this can show up between two different modules if they have to communicate. Right? I run for a little while, and then I stop, and something else runs, and then I run again. Right? Now, over the network, this is irreducible, right? This always happens over the network. You can't get rid of that. You can't always get rid of asynchronicity. However, there are a lot of places where you can get rid of asynchronicity, and it's important to do this. So earlier designs for urbit sort of assumed, I think Philip made this point a couple of years ago, that like earlier designs for urbit assumed that asynchronicity would just be fine. You just deal with it, right? Just get good, don't mess it up. And at some level, maybe this is true, but in practice, better not to. And so I would say that I'll give an example of this, right? So until 2020, there was a separate vein for Ford, right? So Ford was its own kernel module. Ford is a build system. It's a linker and build system. So you can give it a folder full of Hoon source files. It will figure out it has a little language for build directives. It'll cobble together the programs and make one program out of all those files. Right? So this is how urbit will build an application that Gall will then run. Gall is the other kernel module that runs applications. So we're loading files from Clay, which is urbit's file system vein. So Ford will load the files from Clay, do a bunch of builds. That would often have to go back and forth into Clay, and then send the result to Gall. And there's this whole triangle of communication. And the thing is that because all these things were bouncing back and forth, Ford could never really complete anything. Right? It would run part of a build, and then it'd have to go ask Clay for the next, to load the file to grab the next step of that. And this asynchronicity made it so that until 2020, we were never actually really able to perform a reliable over-the-air update in urbit. It was just too hard. It's technically possible to get this right. It's not like a mathematical impossibility to say, okay, well, you keep asking until you get all the files, and then you do what you need to do, right? Like, it doesn't sound like it should be that hard. But it was. And asynchronicity actually really is hard. So in 2020, I think it was Joe's idea, we moved Ford into Clay. And so now Ford is just a function. Clay, the file system, as it's running, if somebody asks it to run a build, right, or if it knows it's supposed to run a build as part of doing something else it does, then it just calls the function, gets the result, keeps going. And since then, we've been able to push out over-the-air updates. I mean, we broke it a little bit the next year, but then we've since fixed it again. But since then, the number of bugs that we've had in Ford and in that whole system have been much fewer than before. And the amount of code was reduced by roughly a factor of 10. So yeah, remove asynchronicity if you can. Something similar is to remove unneeded state. And this goes back to the dongly bits. Often you just have some kind of state sitting around, right? Any computation that's stateful. Maybe it doesn't need to be stateful, right? And so a good example is from Ames, our networking vein, where when I had first written a version of it in 2019, then it had a packet queue, and separately it had a little number saying how long is the packet queue, how many packets are in the queue. So that whenever we need to know how many packets are in the queue, you didn't have to traverse the whole packet queue, right? Because that's a linear traversal. You don't do linear traversals, they're slow. So okay, just cache the number, right? Don't have to run that every time. And then whenever you add a packet, add 1 to the number. And whenever you remove a packet, subtract 1 from the number, right? Just normal, right? It got desynchronized. Like, it just did. Like, you're modifying the packet queue, sometimes I forget to add 1 to the number. Sometimes forget to subtract 1 from the number. And after a while, some ships ran into really bad problems from this. So what did we do? Well, we got rid of the number, fixed the bug. Did it make things slower? Not appreciably. Nobody cared. This is often the case, right? Often as you're programming, you think, oh, okay, I'll add a little cache here, right? I'll add this, there's some derived data, like, oh, I don't want to have to derive it again, I'll store it. Resist the impulse. It depends what you're doing. Sometimes you really do need that, for performance. But that should be a conscious decision. That shouldn't just be sort of a knee-jerk thing. Now, there's lots of state that you cannot get rid of. And so for that, you have the next one. Make the state explicit. This is something we've been learning really over the last year. State can be implicit in a number of ways, but one of the big ways it can be implicit is if it's in pending input and output. So let's say I try to send a packet to Jay. And then I just forget about it. I don't store the fact that I'm waiting for a response from him, right? I'm sending him a message, I want to get an acknowledgement, right? But I could just send him the message, and then maybe I don't need to explicitly track. Maybe I don't technically need to explicitly track the fact that I've sent him a message. And then there's something that happens when I get the ACK, then that triggers me to do something, right? But now what we have is implicit state, right? So I don't have, because I could say, oh, I removed the unneeded state from my system. Isn't that great? But I've only removed the state from my system, and if you zoom out to include the system of both urbits and the wire in between them, that state is still there, but it's no longer explicit. Now only the wire between us knows that that's there. And so then if that goes wrong, something happens in the future, I do a state migration, I change the logic in my program a little bit, I have no way of knowing whether I was in the middle of that or not. Right? So if the state were explicit and I just said, okay, I'm going to send a message to Jay and I'm also going to write that down in my program. There's going to be a field. I have a message that I sent to Jay. Then if I upgrade, then I can look at that, right? Or something else happens later, I can look at it later and say, okay, I'm in the middle of this. So we're in the process of applying this observation in a number of ways. Philip talked about this quite a bit in his talk. So the next one is use level triggering, not edge triggering. This is another analogy from hardware. I guess we're kind of hardware wannabes here. So in hardware, there are two ways of sort of reacting to a change, or reacting to something in the circuit changing. You can react to an edge, which is where it looks like an edge in a graph, right? So if you're looking at the value in a wire over time, it's either 0 or 1, right? There's either no current flowing or there's current flowing. You can look for a transition, right? You can look for that step function, the edge of where it changes from 0 to 1, and you can react to that change. Right? Or, so that's edge triggering, because you're reacting to the edge. The edge is triggering some behavior. Or you can do level triggering, where you just react if it's 1, right? So you read, like, what's the state of this? And if it's 1, then you do something, right? And if you read it again and it's still 1, then you do it. And you read it again and it's 0, then you don't do it. And it's 1, then you do it, right? But you're not listening for transitions, right? You're reacting to the state, not to a change in state. So it's often tempting to write something where you're listening to the transition. Sometimes that's more computationally efficient, not always. But when you're trying to make something timeless, it's much better generally to do level triggering. And what that means in software is that you have something that's a state function, is a technical term, right? It's like basically you decide what to do based on looking only at your current state. You have no dependency on what happened before. You don't care how you got there. It's not hysteretic, right? You just care about what the current state is. And the nice thing about this is that it forces you to write your program in such a way that whatever operation you do there is idempotent, right? Meaning that if you do it twice, the result only changes once, right? If idempotent means there's like one power, right? Has the power of doing it once. Doing it twice has the power of doing it once, right? So, because if you have to just be able to read from that wire whenever, right? And whenever it's 1, then you do the action. Then you may do the action multiple times. And if you build all of your systems so that they're idempotent at all the different layers, you're going to have a much better time. This observation of level triggering versus edge triggering arguably is why Kubernetes is so successful, right? Because instead of listening for like, oh, did somebody run this command? Did one of the 1,000 machines in this data center run this command or not? Right? Or like when it runs the command, you take some action. Instead of that, there's a configuration server that says, here's what all these machines, here's the configuration that all these machines are supposed to be in. Each of those machines reads from that configuration server and says, am I in that state? No? Okay, I'm going to take some action to get myself into that state. And then they do it again. Am I in that state? Yes. Okay, cool. I'm not going to do anything. Right? Idempotent. Right? So that kind of idempotence, like, that's related to it being declarative, right? So you can have a declarative system where you're saying, based on this state, irrespective of how it got into that state, then we're going to make the rest of the system, sort of, as Philip would say, true itself up to what it needs to be for that state. Another one is to reclaim resources predictably, which implies that, first of all, that you can reclaim resources at all, which a lot of parts of Urbit couldn't do in their initial instantiations. And unfortunately, when we had to go back and bolt on some resource reclamation in different places, sometimes that made the system pretty ugly. I'd say that especially in AIMS. The way we close AIMS flows, which are sort of like sockets, is we had a lot of bugs with that. And it's a little messy. And we did have to close them. But if we designed the system from the beginning to have clear life cycle semantics about flows, then I think we wouldn't have gotten into that position in the first place, right? So when you're designing the system, make sure it can clean up after itself. Make sure that any resources that it takes a lease on, that it can relinquish those resources. And we think of this in terms of system software, that's operating systems and other things that are running other code. But if you have a sufficiently mission critical application, then this is also true. Okay, this one's sort of interesting. Locate responsibility properly. And this is subtle, and I feel like I haven't heard people talk about this, but I don't know why. So because I think this is very important, actually. So basically, it's important to figure out which piece of code and which user should be responsible for what, right? So for example, we had a problem for, I don't know, 5 or 10 years until very recently, where if I were just a ship running and you send me a poke, you send a command to some app that's running on my ship. I'm not running that app yet. Then you send me that command, and my GAL that runs my apps will just enqueue the command. And if you send me a second command, I'll enqueue that one. And if you send me a third command, I'll enqueue that one. And you can actually just keep doing this. And if I never start the app, you'll just fill up my ship. You'll fill up my whole machine. And then my urbit will fall over and never be able to run again. So the fix for this was to make it so that if I'm not running the app, I actually just reject I don't reject the request, I just drop it. And what that does is it moves the responsibility of maintaining the queue of commands that you're trying to send to me to your ship. So if you want me to do something, okay, you store that information. I don't care, right? It's your responsibility. It should be your responsibility. The fact that it had become my responsibility was a big problem, because now it's a security problem, right? That's a DDoS attack, or not even DDoS, just a denial of service. You don't even need to distribute it. It's just one ship. But this shows up in a lot of, in more subtle ways in a lot of other ways, I would say, right? So another thing that we did last year was move the source of truth for which apps are supposed to be running. We moved that into Clay, the file system, which sounds a little weird. It's like, well, wouldn't you want that to be in GAL, right? The kernel module that runs the apps? Wouldn't you want that to be the place that has the sort of ground level understanding of what it's supposed to be running? But actually, because Clay manages kernel updates and manages the build system and manages the file system updates, and it needs to do all of that atomically, Clay has to know which apps are supposed to be running, because if you're not supposed to be running it, then it doesn't try to build it. And if it knows that it doesn't need to build it, then it can actually do the kernel upgrade. Right? So actually Clay needed to know. So moving that responsibility into Clay, now that system works better. Now, arguably, you're hearing like, okay, this is kind of going back and forth and it's not that clear. And so that's because there's asynchronicity. So hey, maybe we should stick Clay and GAL together and get rid of the asynchronicity. And sure enough, we've been thinking about this for a few years, and I bet that by 5 or 10 years from now, we will actually do that. I could be wrong, but I think we probably will. So that's a little subtle, but low-hanging responsibility. But this also applies to the network layer, right? Like, what should a star be responsible for? What should a user be responsible for? What should a moon be responsible for? So it's important. And there's an interesting thing where the responsibility for something often means also the power to do it, right? So with urbit, I have the responsibility of storing the data for my ship, running my ship. That also gives me the power to do it myself, right? And so because these things tend to align, it's like, yeah, if you want to sort of empower an individual to do something, then they also are going to end up bearing responsibility for it. And these things are going to tend to align. So you want to think about this even at a sort of social layer. All right, the last two are more process related. Second to last one is incrementalism. So what this means is we're not going to jump all the way to the perfect computer. The Arvo kernel is at Kelvin 250 roughly. Standard library is roughly 412 as of a week from now. Speaking in the prophetic future. So we have a couple hundred changes that we can make, a few hundred. Right? So each one of those changes is not going to get us all the way to the end. It's not going to be perfect, and that's okay. It just has to be better than the last one. Right? It just has to be giving us constant progress toward where we need to be going, and it needs to be big enough progress, right? But it's important not to get stuck and think, well, that's not perfect, so we're not going to put it in the kernel. It's like the kernel already isn't perfect. It won't be perfect for a long time. Getting it to be closer to perfect is better than not doing anything. So it's important for us to have that attitude. Now, what's something I didn't mention here that's also important is the opposite of this, which is that sometimes you have to be able to look at a part of the system and say, this sucks. And actually, we should rip it out entirely, or replace it with something that's a totally different design. And we have to have that flexibility. We're not yet at the point where we can say all of the major designs for all of urbit subsystems are exactly what they will be in perpetuity. We have to be willing to make some hard calls sometimes, make drastic changes if they're needed, and quickly. So we can't yet afford to be dogmatic. Maybe later, but not now. And this is related to the last point, which is we have to listen to users. This is very important. You can go build the perfect system in out in some lab somewhere, and then everyone else just moves on with their lives. Or you build something that's good for one particular use case that you're really thinking about, and then it turns out that's not a big use case, and there are 7 other use cases that are much more important. Or it's the perfect design at some abstract theoretical level, but it's absolutely impossible to use. Nix comes to mind here. No, don't mean to cast shade on Nix. I think they have a very difficult problem to solve. But so I think it's important, and the users for Urbit are actually mostly developers, right? So for the Urbit operating system, like all operating systems, the primary users of that are developers who use the operating system to build applications that run in that OS. Right? So for us, the users are primarily of the kernel space are primarily user space developers, also end users, but it's mostly like we need to be listening to the people in this room. So we're trying to listen, certainly come to us. We try very hard to be responsive to the needs of Urbit companies. All right, so where are we now, right? Like, how far have we gotten with this stuff? What's the situation that we're in now? And I would say that the way I'm thinking about this at the moment for core dev is that we want to get to what I'm calling Urbit 1.0. This is not a technical version. We're not going to put it out in the release notes or something. But it's the idea of just what does 1.0 mean in general. It's like, okay, that's the first version that was real, right? That is deployable, production level, industrial software, bulletproof, right? And okay, maybe it's not all that fast, and maybe it doesn't have every feature you need, but it's been deployed for real, right? It's no longer an alpha or a beta. It has made it to 1.0. And I don't think we've really gotten there with Urbit. And we need to get there within about a year. We have roughly 1 year to get there. We just have to. So I'll define what I mean by this, and I'll also talk about why we're not there yet and what we need to do to get there. So the rest of this talk is going to be mostly about getting a little bit into the weeds of what specifically are we going to do to fix what specific problems, and where do we expect to be 6 months from now, a year from now. And I'll have a little fun at the end. Not that much fun, but a little. We'll talk about Urbit 2.0. So Urbit 1.0 will fully support social media applications. I say fully to distinguish it from the current condition where I would say, partially support social media applications. Certainly there exist social media applications on Urbit, but do you feel supported? Probably not. So here's what I mean by social media applications. I'm going to broaden it a little bit from what people usually mean to include some stuff relating to magical internet money, basically. So groups, chats, and DMs. This is like the Talon suite or the Holium suite. This is something this is the main sort of daily driver of what people do with Urbit right now. But yeah, this has to work. It has to really work, right? Actually, what this means is basically Urbit, the operating system, needs to ensure that any of these apps can have the same feature set as Telegram or whatever the best in class is at the time. Blogging and microblogging, so Substack, Twitter, right? These use cases have to be supported. Urbit, the operating system, needs to make sure that if you go and write an app that does this, it works, it scales, it's secure, it's reliable, it's performant, et cetera. Media sharing, Grug won't put movie in Urbit. Grug won't share movie with Chase. Right, so it's a taller ask. It's a taller order than just being able to store media. It also means that I need to be able to share that media with you, and that means that probably we need more network bandwidth than we have right now, right? Like, because that could take a while at current speeds. Serving web apps to the clear web, right? So actually, Urbit should be a viable SaaS platform, right? It's like, okay, you can use LAMP, you can use Ruby on Rails, or you can use Urbit. It's a web server. It should work. It's not that far from it, but this has to work. Actually, Kelvin 412 has a couple of features that get us a lot closer to this. The next is DAO management tools, distributed autonomous organizations, or is it decentralized? Kenny and I were debating this earlier. Whatever, decentralized. All right. Well, whatever they are, they have to be able to manage themselves on Urbit. Yeah. Well, okay, so I'm joking a little bit, but this is serious. There are a lot of people running DAOs. And there are a lot of people who would like to run DAOs, but it's not easy to do. And so there are a lot of, it's not easy to manage a DAO. People have to cobble together all these different tools and all these different things. They each have their own login. Sometimes they censor you, kick you out. Or, they don't integrate with each other very well. Different ID systems for each one. So Urbit, this is one of the major sort of general product categories that we've been thinking that Urbit is well suited for over the last year or two is tools for managing DAOs, because you can have your groups and your chats and your voting app and all these other things and your document editing and all these other things, all unified under one ID. The applications can interop with each other. It's pretty seamless. You store all the data in one place. You don't have to install lots of different stuff, right? So there's an easy kind of story there, right? So Urbit has to actually work for this. And so this means all the other social app stuff, and then also it has to be able to have reliable connections to blockchains. Right? That's the other sort of big implication. Similarly, crypto wallets, and the big thing that you would want for that is a real security story. Right? Urbit is not secure. Urbit is not secure. You should know this. Sometimes people forget. We do tell people, but it's not. It needs to be, and it will be. But at the moment, it is not. Do not put your keys in there. But you need to be able to put your keys in there. Okay, you don't want to put the keys that you're going to give to your grandchildren in there, right? But whatever you would be comfortable putting in Coinbase, you should be comfortable putting in your Urbit. The last one is actually pretty similar to the serving web apps, but also requires this a security story, which is you need to be able to run web stores from your Urbit. And you need to be able to do monetized software distribution. So you need to be able to manage that from your Urbit. Right, so like what Chase was talking about earlier with vaporware and having an NFT-gated software installation. It's like, okay, well, you want that to be secure, actually. Right? And you want it to be reliable and all the other things I'm about to talk about. But just noting, that's something to keep in mind as a feature that needs to be supported. So there are 4 categories of what's missing, why we're not there. And I will actually go through these, but you'll be asleep, and then I'll talk about how we're going to fix them. Reliability, performance, developer experience, and security. So all these need to improve. And they need to get basically over the hump. I use this phrase a lot. Right? Urbit needs to get over the hump. Each of these needs to get over the hump to a place where it's supporting basically the set of applications that are either actively being built on Urbit or that we expect to be built shortly. So the first is reliability. There are a lot of reliability problems right now. I would say the biggest is that when I try to have a peer-to-peer connection with you, my Urbit tries to send your Urbit a message. Sometimes it flakes out. Sometimes it doesn't get there for an hour. Sometimes it doesn't get there for a month. Absolutely untenable, unacceptable. So Joe gave his talk yesterday about how we're fixing that. But that's something we're fixing right now. There are some error handling problems in the kernel. So if an event that we try, any event that urbit runs it's like a database transaction or blockchain transaction. It can fail, that's fine. And then the system just rolls back to the previous state. But there are a couple of things that can go wrong after that, where with urbit, sometimes that event needs to try again repeatedly until it succeeds so that the system can make progress. Or if it fails repeatedly, then the system needs to, because it's running some user space app that was written by someone who uses Hacker News a lot, then the app never recovers from the error, and the system needs to understand that that app is now in a bad state, and the system needs to make progress despite it. Right? There are a couple of other things like this, like little details of what the error handling pathways are in different cases, and there are a couple of known flaws there. We need to nail down all of those. Memory limitations are another reliability issue. We usually think of, so you can only store 8 gigs of data in your urbit. It's actually usually 2 gigs, but you can bump it up to 8. And this means that sometimes as your urbit is running and it's doing some computation, that computation tries to use more than 8 gigs, and it crashes, right? So that event crashes. I call it this, so this is why it's a reliability problem, not just a sort of storage scalability problem, is that it means that sometimes stuff just doesn't work because we have a limited amount of RAM to play with. So you'll see the bail meme error message, which means you've hit that. Here's a big one, buggy kernel updates. So I know this has been a big problem for a lot of people. Yeah, I apologize about that. That's just something we have to do better on. Our current best idea for how to do this is that before we push out anything, we make sure that all the new code gets exercised and as close to a production environment as possible, ideally as many of them as possible. So every major urbit app company or developer will actually run the code in as close to their production infrastructure as possible before we sign off on it. We also have our own testing checklist that we do ourselves and we encourage other people to run. There's probably more work to do on that subject, but as urbit, in order for urbit to be bulletproof 1.0, kernel updates need to not break it. They need to just work. So that's very important. As I mentioned earlier about the public key infrastructure and jail, learning other people's public keys, that pipeline is fragile. It can flake out. I think the Vaporware guys are just hitting this with another Ethereum client application, right? Yeah. So, so while jail itself, the vein, I think is probably fine. That pipeline is fragile, so that has to not be fragile. That has to work. It has to be very robust. And finally, there are flaws in suspending and reviving agents. So an agent is an urbit application. It's a program that runs in user space. Gall, the kernel module, runs it. And if you can turn them off and on, sort of like shutting down a Mac app. It's actually a little different because it's a long-running service, right? But it feels like that, like turning off a Mac app, and then you can turn it back on. And if you turn it off and then back on, Gall doesn't maintain all the invariants that it claims to maintain. So if you're waiting on subscription updates, or you're waiting for an acknowledgement for someone else, or you're waiting for a timer to elapse that you had asked the kernel to set for you, those will all get dropped. And then when you wake up, you don't know that you were suspended. So it's very difficult as a user space programmer to correctly handle that, because you don't know that it happened, you don't know what was lost. That information is generally irretrievable. So that's also untenable. We just have to fix that. We have to fix all of these in order for this to be a reliable system, right? And it has to be a reliable system in order to say that this is a piece of real production software that people can build on top of, and they're building companies that this is what they do. So the next one is performance, maybe performance and scaling. And the first item here, and I would say by far the biggest problem with performance at the moment, is the 8 gigabyte limit. Right? This is the big thing that needs to be improved on, if for no other reason than there's a psychological impact of it. Right? If I know that the system can only store 8 gigabytes, then I'm not going to build a file sharing system, even if most people wouldn't actually share 8 gigabytes. But just the knowledge that it would hit the wall, it has a chilling effect. And it's not purely psychological. Also, like, plenty of people do have way more than 8 gigabytes of data that they want to store. I can't put Llama 2 into my urbit because of this. This is why. As soon as we have a 64-bit interpreter that can handle this kind of data, I can store Llama 2. I can't yet run it. We're working on that. But I can store it. You have to be able to store it before you can run it. Next one is network bandwidth. And I mentioned this earlier, right? So for media sharing, if I have a lot of data, I have to be able to transfer it to you very quickly. So I have to be able to crank up the speed, max out an internet connection. I mean, maybe not max out your 40 gigabit, InfiniBand or whatever, but like a typical network connection, max that out. For social applications, right? So for video streaming, video calling, that's probably the highest bandwidth that we really need. But it at least needs to handle that and handle it well. The third one is NOC performance. And I don't put this at the top of the list. Like, NOC is slow. And we're putting a lot of effort into making it go faster. But it has a linear performance improvement on everything in the system, right? Like, roughly. Right? So something, if you make it twice as fast, then something goes from taking, 100 milliseconds to 50 milliseconds. So, right, so you can do twice as much stuff. But other kinds of performance work has superlinear implications. So, especially at the network level, where you might be broadcasting a piece of information to many different people, right? What Joe was talking about is dissemination in his talk. Nevertheless, NOC performance is important, and it does have to get better. So we are working on it. And I would say this is the first time we've really put a concerted organizational effort into NOC performance. The bytecode interpreter was dropped on us by one guy who works part-time. Yeah, Merry Christmas. It's great, but it does not constitute organizational focus. So the last three, load on publishers. Disk, so a publisher on Urbit is somebody who's hosting data that they're publishing to other people, right? So you're hosting a chat, hosting a blog that you're publishing. Maybe you're publishing source code for an app that other people can install by downloading it from your ship. Any of those things, the disk and CPU load on those publishers tends to be quite high. And that can be a scaling bottleneck, right? So there are several thousand ships on the network right now. If you imagine that going up to 40,000 or 400,000 or 4 million, what breaks? This is one of the first things that breaks. Similarly, there's load on relays. So that's the sponsorship hierarchy, stars and galaxies. Tacen hit this really hard earlier this year. And we put a Band-Aid in place, so they're okay now, but we need to actually fix that. Finally, this one's sort of interesting. There's a lack of quiescence. So quiescence means like the state of being quiet, roughly. And with computer systems, it means that the system isn't doing anything. It's idle. It's not in the middle of something. It's not sort of under load. And Urbit never really gets to that state the way it is. It's kind of loud and insistent, especially with the disk, which is particularly bad for Native Planet and anyone who wants to use their own hard drive when running Urbit, because it's just pounding the disk over and over and over again. Every time Urbit sends 1 kilobyte of data, pound the disk. Every time it receives 1 kilobyte of data, pound the disk. Every time it was expecting to receive a kilobyte of data and didn't, pound the disk. So it just burns through hard drives like nobody's business. But what that means for Native Planet is that their hard drives don't last as long, and then this is a big problem. And that causes all kinds of other problems for hosts as well, because for a host, you really want to be able to take an Urbit and shut it down. And like Tacen can do this, but it's not easy for them to do that well. This kind of goes back to state, actually. Unneeded state and unneeded state changes. You only need to do a disk write if you're changing state. So stop changing the state, alleviate the need for disk writes, get to quiescence. Very roughly. There's a lot of details there. All right, so we've done 2 out of 4. Reliability and performance. The next one is developer experience. Then we'll talk about security. And then we'll talk about what we're actually going to do about this. How many of you have used a Gall subscription? Raise your hand. All right, it's like 3/4 of the room. Did you enjoy that? They're very difficult to use properly. It is probably possible to do it absolutely correctly. It's not entirely clear that it's completely possible to do correctly. And that's just, that's not how we want to be talking about like a major piece of the application model in Urbit, right? Like, it has to be a lot better. Nobody says this about pokes, right? Like the commands, or Urbit, like one app sends a command to another app, like, okay, if you can miss the ACK if you're suspended or if there's a breach, but other than that, pokes work, right? They just work, you just do them. They go through, you get the ACK, you don't think about it. So whatever our subscription system is, and we do need a subscription system, because dissemination is the vast, vast majority of what people do with computers. Whatever that system is, needs to be very easy to use correctly. And it should be relatively easy to use in a performant manner as well. But it especially has to be the case that if I write an app in a weekend, and I slap a few lines of code together and set up some kind of publication, that needs to work. And I don't have to, I can't have to think about it. It has to work without me thinking about it. Okay, so actually, the next line here is scry namespace limitations. And the reason that I call this a problem, even though it's more of like, well, we need more of a solution, is that this is the solution to the Gall Watch subscriptions problem, among other things. So right now, Urbit has Urbit, since 2010, has had a scry namespace. And that is, it's basically a URL system where every URL is a permalink, and it starts with the ship that's hosting the data. So if I'm hosting data at robnusrickfer/Gall/chat/my chat channel/message33, you can read that from me over the internet using our remote scry network protocol. And that scales well, and it's easy to make correct because it's immutable, right? So it's solid state, going back to those principles from the very beginning. However, there are limitations to what you can do with this right now. So it's only usable for public data, not private encrypted data. You can't just send like, hey, what's your latest? I have to somehow know what your latest revision number is before I can ask that. And there's no way of asking for the next one in a way where I'll get the response quickly. So I can't really use it for live subscriptions. That's really the blocker for using this for chat. So all those limitations mean that we still kind of need Gall subscriptions for now. Right? So we have to get rid of those limitations, kill the Gall subscriptions, and then we'll be in a better state. Package management is missing. Right? So if you're there's just no solution for this. If I'm If I'm writing a Gall agent that I deploy to the network, right, and that Gall agent needs to communicate with several other Gall agents, it needs to import some libraries that other people wrote. It needs to import the sort of header files in Hoon that describe the data structures that I'll use to communicate with them. There's no tooling to help with that. So I'm going to have to manually copy and paste files. Whenever something changes, I'm going to have to manually set that up again. Perhaps I use something involving symlinks. But it's very annoying. It hurts our claim that you don't have to do DevOps with Urbit. And you still don't have to do as much DevOps with Urbit, but you still have to do that, and that should be much easier. So it's unclear if that should actually be something like a kernel feature or even something that just lives in Unix. Hard to say, but certainly it's a problem for developer experience. And the second to last one that's technical is breach handling. So if I breach, right, and then there's code that's running. Oh, sorry, I skipped agent backups, which is related. So agent backups is a really big one, and Native Planet actually has a UIP upcoming for how to do at least part of this. But in general, what users want is that they're running their Urbit, and they periodically take a backup. The backup does get a little stale, but if they lose their actual Urbit, they want to be able to restore from the backup and have some kind of reasonable functionality. And so they want all their apps to understand that they need to be able to load from a backup. right? And that has to be as seamless as possible and has to lose as little data as possible and get back into a consistent state. So we don't handle this situation very well right now. So there's a UIP coming for making this at least possible. It'll be sort of opt-in on an agent-to-agent basis, but actually the application model itself is not very good for handling this sort of thing. So that's something we're keeping in mind. Similarly for breach handling, if I breach, right, or if someone else breaches, it's not clear that we actually handle that with full consistency. The last one is just quality of life issues, because developer experience, yeah, there are these big ticket items, but a lot of it comes down to like lots of little things. And a lot of those little things could be a lot better. The Hoon Pretty Printer is my favorite thing to pick on here. But there are lots of little things, lots of little queries that you should be able to do to Clay and Gall, right? Lots of what? Compiler warnings. And errors, yeah. Yeah, much better compiler errors, dojo errors, right? Why didn't your generator work? Who knows? An IDE?
LSP for whom finished.
LSP for, yeah, right, lots of stuff like that. Editor, generally backing up, editor integration, right? All right, so the last category, security. I'll go through these a little quicker. So the first one is front-end sandboxing, which means that when you actually use an Urbit app, you use it from the browser almost always. However, the way it works right now, that browser code can just access everything on your Urbit. It can send commands to all the different applications. There's nothing stopping it. So we can't have user space permissions, which means that the kernel protects itself from apps, and apps are protected from each other. And with this sort of like glaring hole in that whole system, it just doesn't really help for him. It would be the Maginot line of Urbit. Somebody told me this yesterday. I stole the joke. I can't remember who it was from. Neil, thank you. So we need front-end sandboxing. There's a way to do this. And then once we have that, then we can build user space permissions. That's actually mostly built, but it needs to be kind of, there are 2 or 3 loose ends that need to be finished there. And then we also need to protect the Urbit machine, we need to protect the rest of your machine from Urbit in case Urbit gets hijacked. Right? So that's sort of security going the other direction. The big way to do this is to drop the permissions of the Unix processes that are running. Very standard Unix thing. Probably not very hard. If any of you are interested in doing this, just try it. There are a whole slew of denial of service mitigations where somebody tries a denial of service attack, and there's a way that we can fight against that. The big one that we're probably going to hit over the next year for Urbit 1.0, there's a long tail there. We're not going to hit all of them, but we'll probably hit one which is what we call, or what's typically called the fail to ban strategy, where it's like if I'm getting a lot of requests from some IP address and port, and then those requests keep failing, then rate limit that IP address, right? Just stop listening to them for a while, or listen much less. All right, so it's a very kind of simple heuristic, but that gives you some basic protections against DDoS attacks. So the next ones have to do with the runtime security, right? So Urbit has its virtual machine written in C that runs knock. Like all large programs written in C, you have to check it really carefully. And actually, the next version of it is written in Rust, but hey, it's written in unsafe Rust, so you're still going to have to check it really carefully. Maybe a little bit less carefully. But so there's fuzz testing, where it's like, all right, we're just going to spin up, or maybe we'll ask some security firm to do this, to say, okay, just spew garbage into the UDP port and see if you can take down a ship, right? See if you can get it to crash, right? Spew garbage at the HTTP port and see if you can get it to crash. Maybe spew things that look a little bit less like garbage and see what you can do. But this is fuzz testing, right? You're just probabilistically searching for security failures. We need to do the same thing with jet memory integrity, right? So the jets are these functions written in C that re-implement the same functionality as some knock function, but faster, so that the interpreter can use that instead. And So all of those are part of the security attack surface. And so all of those need to be fuzz tested to make sure that they all handle memory correctly and can't be exploited. And then the last one, which I don't think we'll get to in a year, is formal verification of between the NOC and the C code. So that's a mathematical proof, which you could do by hand, but mathematical proof that the logic of one of those functions is exactly the same as the logic of the other function. So there is a way to do this, but that'll probably happen a little later. Okay, we made it to the problem, through the problems. So there are just 2 slides of what we're going to do this year and next year. And then we'll get to Urbit 2.0 as a little treat for making it this far through the presentation. So the big project that we're doing right now, probably the largest effort, is Aries. Aries is a clean slate rewrite of the NOC interpreter, led by Edward Amsden, who works at Zorp. It's a cross-organizational effort from Zorp, Talon, and Urbit Foundation. And this is a large effort with several people working on it. So this is a 64-bit interpreter with what's called a persistent memory arena that can manage up to, I believe, 16 terabytes of data in the last design. And it has a novel optimization technique for NOC. So it should manage terabytes of data and also have, we'll see how much faster it is. We're all expecting in the range of 10 to 100 times faster than what we have current. Maybe not immediately, it might take some tweaking, but it'll get there. It's also more amenable to parallelism, multi-threading, yeah, we're all excited about it. So we're working on that this year, but we don't expect it to launch until January or February of next year. And then by February, we expect it to be the case that over 50% of Urbit nodes, Urbit chips, are running Aries. So it's aggressive. This is an aggressive timeline, and we're going to be putting a lot of focus into this project. The next 2 are what Joe talked about yesterday. AIMS informal sponsor pinging, and AIMS and FINE unification, which has the the name directed routing is the name of the UIP. It's actually a much bigger change than that. It sort of undersells what it's doing. But so these are going to rectify the scaling problem with relays, and also the reliability issues with connectivity. It's a much simpler model for networking and for routing, and so we expect this to just crush the bugs that we've been experiencing, and make it so that it's much easier to analyze, much easier to debug, and we're just going to debug it, get it out the door, and it's just going to work. Right, Joe? Then we just heard a talk earlier on the next one about VAR, persistent NOC memoization caches. So Matt Levan has built those. Those are just about done, and we're going to make one or two uses of them. And this is like low-level work that makes a lot of other things above it easier to work on, because we can strip out a lot of state from different parts of the kernel, and it gives us opportunities for doing network protocol optimization that we wouldn't have otherwise. So not much is going to come directly from just that step. It's in the steps right after it that are going to help a lot. Breadth first move ordering in Arvo. This is a way of dealing with some asynchronicity, I would say, right? So when, and this is another sort of relatively low-level feature. This is the one thing we're changing about Arvo. Remember earlier, it was like there's just one thing, and hopefully this is not like Lord Kelvin in 1890 saying there are only 2 problems with physics, one of which led to quantum mechanics, and the other one led to relativity, right? So, so there's just one problem with Arvo. Yeah, so the way Arvo handles effects between kernel modules is if one kernel module emits 2 effects, then it takes that first effect and it delivers that to the kernel module and runs all the ones that come after that, and then traces that whole tree. So what we call depth first move ordering, because it goes all the way down the tree of possible effects from that. And only once that whole thing is finished, then it runs the second effect that the first thing ran. So we're depth first traversing everything that comes after the first move, and then depth first traversing everything that comes after the second move. And then there's a certain elegance to this, but in practice, you end up with a lot of weird stuff because that first move can trigger other things, and then you lose the chronological ordering of the effects. So you can end up with moves coming in out of order a lot, like in reverse order from the way they're emitted, and it's very difficult to reason about this. Your mind kind of like twists around a corner. At least mine does whenever I encounter this. So breadth first move ordering is the opposite. Arvo runs, there are these two moves that come out of one vein. If they're to two other veins, it runs both of them logically in parallel. So there are no data dependencies between them. It's logically simultaneous. This introduces a new concept of synchronization within the kernel that wasn't there before, which also enables us to pin the scry handler and establish full referential transparency for that. And also we could run it in parallel if we had a parallel runtime. It's probably not that big of a deal, but it would be nice. Generally, a lot more sanity, a lot easier to reason about. So we're doing that this year. It's going to happen. We're also working on scry over HTTP, right? So that scry namespace where you have this permalink, it starts with your ship, and you can request data at that. Right now, it's only urbits that can read that from each other, but there's no way to read it over the web from a browser. So we're exposing that. We're going to make that so that doesn't do a disk write, recurring theme. And but that'll be very nice. You can just download files into the browser, load files. It'll do file type conversions. There's a UIP for it. There's a nice full spec for exactly how it works. So feel free to check that out. And finally, encrypted remote scry. So earlier I said there are limitations with the scry namespace and the way you can use it. One of the big limitations is that there's no way of publishing data to like only a small set of people and maintaining the privacy there. So by encrypting the path and encrypting the data at the path, we can still use that scalable dissemination network protocol and still use the scry namespace for its solid state programming benefits, but actually have that go over the network and have that work and have it be private. So those are the big ticket items for this year that we plan on deploying by the end of the year. Then I'll also talk about the first half of next year. All right, so by the end of the first half of next year, we expect the urbit to be at 1.0. That's right, Matt. So the order of operations here, the exact set of projects gets a little murkier because it's a little further out. And there's a good chance that by the time we hit the beginning of next year, we'll have better ideas. This happens a lot. So I'm not committing to this exact sequence of projects here, but this is roughly the shape of what we're going to be working on mostly, and there will also be a lot of other little things that come in. But here's the general set. So Aries production deployment, January, February, getting out the door. It may not be much faster than current system. It may even be slightly slower, but it'll be able to handle the 64 bits of data storage, and it should be stable. So the next one is called Pine, or as Josh Lehman pronounces it, Pinay, to rhyme with Finet. So what this is a network request for the latest value in the namespace. Earlier I said you can't do that. I can't just be like, hey, what's the latest value? What's the last chat message you've heard? Can you send me your last chat message? You can do this with HTTP. You do it all the time, right? And you just can't do it with Urbit. It sucks. And we need to be able to do that. And we need to be able to use scalable dissemination through the scry namespace with solid state. You know what I'm going to say now. So Pine is something we're going to build that next year. That's part of the solid state subscription story. We have to have that. And that's actually something that will just improve the developer experience in quite a few ways. Because things like Docker and Docket and Treaty, Freudian slip, are like, a lot of those apps actually probably shouldn't exist. And those should just be queries that you can ask Clay or Gall in the kernel, but you have to be able to ask them with a Pine. So this is another thing that should just reduce the size of the code base, strip out a couple of extra layers in a few places. Gall step nomadism is the next. So Philip wrote an excellent essay about step nomadism, in contrast to step wisdom. This is how we're going to fix agent suspension, and in general fix a lot of the application programming model in urbit. And so this has to do with making state explicit, making all pending input and output tracked by the kernel and available to the application, and available to a later agent that was pulled out from backup, right? That was restored from a backup. The backup should include all pending input and output, so that when that backup gets injected into the next version of the ship after a breach, that next version of the ship can tell what the previous version was in the middle of doing. This may eventually lead into what we call a shrubbery, which is basically that same idea but laid out as paths, values at paths in the namespace. Maybe, maybe not, but it's certainly a lot closer. But it's a big change to the application model. You'll end up thinking about your Gall agents in a significantly different way. But we have to get this done by a year from now. Like a lot of these kinds of changes, it's probably not very much code in the kernel to change it. It's just a big difference in how we think about it. The other one is Gall desk-based agent namespacing. How many of you know that if I install app foo and app bar and try to install app bar, then if app foo has an agent inside of it called debug, and app bar also has an agent inside of it called debug, that I will only ever be able to install one of those two things. Rage-driven development. So the solution to this is that when I as an agent send a command to another agent, instead of just saying, okay, it's this ship and this agent name, I'll say it's this ship and this desk and this agent name, and that way they're namespace. This is what namespaces are for. In fact, I think that should be a path, but we can fight about that later. All right, and the last big ticket item has a couple of components, but it's user space permissions. So this is a system that's sort of like your iPhone permissioning system, right, where it's like, this app wants to use the camera. Do you want to let it? Right. Somewhere between that and like an OAuth system, like log in with Google, is like this app wants to see your contacts, and right, it wants to send messages to your friends. Right. So we have to have a system that's somewhere in between those, and then the kernel needs to enforce that. Right, so there's a user space component that actually shows you these modal dialogues and does redirects on the front end and all this fun stuff. And then on the back end, we actually just have to enforce the rules. And there are a couple of difficult pieces here. So front end sandboxing has to happen. I talked about that earlier, but that's the browser-based security check. That has to happen first, so that it's sort of real and complete, doesn't have a big hole in it. And second is that the first version of this didn't really handle kernel updates properly. And it's actually a difficult, thorny problem. So we probably need something like, I'm proposing we use this system called Ulam, which is this little JSON-like language to describe those data structures, describing the permissions, so that an old kernel can read the permissions that an app wants from a new kernel without having to upgrade into the new kernel first. So you need a data language that the old kernel can read and interpret and display something reasonable to the user. We have to do that somehow. So we need those two things, and then the actual user space permissions where it can be deployed. The way I see this is probably going to be like an organizational effort that comes after the Aries deployment. So we're going to deploy Aries, then put out the next fires for a month, and then hopefully they're not that bad, but there's going to be something. And then we'll switch to, as an organization at UF, focusing mostly on user space permissions because it's pretty big. And then we'll get there. So that'll get us to urbit 1.0. And after that, you can, writing an app on urbit should feel like writing an app on Linux, right? Where like you write the app and there's some bug. You don't think, oh, like it's a Linux bug. It's like almost certainly not a Linux bug, right? Like, we have to get to that point, right? It's like, oh, there's something that doesn't work. Like, okay, probably the app dev messes up. We can't say that right now. Okay, so that's urbit 1.0. What's urbit 2.0? Right? We don't talk enough about this. I think we're like, where are we going? Right? And like, what are some things that you can do What are some things that the system can do? What does urbit the system even look like 10 years from now, 20 years from now, 30 years from now? So here are a few things. One clear one is you got to be able to stream video into and out of your urbit. You got to be able to store, train, and run your own machine learning. This is like import Llama 2, tweak the weights with your friends or on your own, based on your own data. Right? You see Portal is already doing this, but they can't do it inside of urbit yet. Right? So collaborative training of AI systems, machine learning. I got into urbit in 2016, 2017 because I was interested in doing large-scale distributed computations on it. I still think that I still want to do that. And urbit should be able to do that. Internet of Things support, Native Planet's starting to work on this. But this is why we have moons. We have moons. Every time you when you buy a planet, you buy 4 billion addresses. It's kind of a lot. Right? Like, what are you going to do with 4 billion addresses? It's like, well, you could run an oil pipeline and all the sensors in it. Your urbit will turn into your personal CDN. This one we're actually not that far from. And as for the LLMs, if we have data storage and we get some jets on the already existent neural network code in Hoon, then yeah, you can go ahead and run WAM. So that's also not that far off. Disputations about floating point non-determinism notwithstanding. We're just going to have to figure it out. But yeah, so personal CDN, we talk about this a lot with remote scry, right? And this general idea of like, okay, my ship, I'm running it on my laptop, but what if I make a post that goes viral and millions of people are trying to read it? What you need there is you need a data center in the cloud, right, that handles those requests. A star should actually be a data center in the cloud. And so my star, my sponsoring star, should actually be able to field those requests for me. And so then it just, it's in, let's say, AWS. And when it starts getting lots of requests, it spawns a bunch more horizontally scaled Scry cache servers. The Scry cache is embarrassingly parallel. It's very easy to scale horizontally. So there's this idea that peer-to-peer systems can never scale. And I just don't think that's true in urbit. And I think what they really mean is, Kademlia doesn't scale, distributed hash tables don't scale, and blockchains don't scale. And urbit is none of those things. So the next one is async parallelism for the main event loop. What this means is that instead of, let's say I download some source code for an app, and then I want to compile it, and the compiler, let's say, is still slow, then I shouldn't do that as one item that blocks everything else I can do with my urbit and locks up the main event loop. We need to do what Node.js programmers have been doing for 12 years, which is you kick it out of the main loop. All right, so you have a long-running process, you kick it out of the main loop, it finishes asynchronously, you inject the result back in. Totally doable. Joe has a very clever design for how to make this not use a ton of disk writes. Parallelism should be a lot easier with Aries, so we might actually just go ahead and build this sometime soon. What that enables is that you have fast twitch response from your urbit no matter what it's doing, even if it's compiling 10 things and running an LLM and whatever. That's all happening asynchronously, you don't have to worry about it. Run WebAssembly in Knock. You want to write your code in Rust, compile it to WASM, and run it inside of urbit, you should just be able to do that. We have a grant out for this. Actually, I don't know if the solicitation is out yet, but we at least have a proposal out, and the solicitation will be out soon if it's not already. But yeah, you should just be able to do it. No reason not to. Similarly, I want us to add a scripting language. Hoon, as I mentioned earlier, is a systems programming language, which means it's statically typed, low-level, concrete, compiled, right, as opposed to interpreted. There are lots of scripting languages out there. They're really useful. The further up you get up the stack you go, the more useful there are. Right? Nobody's going around writing, little scripts in C++. Right? No, you write your script in Python. You write your script in something, Ruby, Lua, something like this. Right? That's what they're for, little glue languages. So we need a little glue language in urbit, and I think that it should be as different from Hoon as possible. Well, we should have a couple of them, actually, but one of them should just be the most normie of normie languages. I actually think that we could implement Lua, like the exact Lua spec in urbit, and give it imperative access to the kernel, so you'd have like what feels exactly like a Linux-style syscall interface, for example. We should have that. We should have something that has algol syntax like JavaScript or C, right? Just we should have a bunch of these, actually. Real-time graphics. I think this is actually doable at a certain point. The way it would work is every 10 milliseconds, so 100 times a second, scry in parallel, a computation out of your urbit that you can use to construct a frame. And that gets jetted with a bunch of code that interacts with the GPU. You could jet the whole top-level thing if you wanted to. I don't think that's as far away as people seem to think it is. Now, I don't know about really maxing out the machine. Probably won't get there, but you could do some stuff. Similarly, urbit native UI, right, would extend nouns and the urbit programming methodology out to the clients, right? So you'll still have a runner, renderer type thing in iOS and in the browser and in GTK or whatever. But you could ideally write that once in urbit, and maybe it still has some limits on its use cases, but it's not clear to me that the DOM model of the web page is really what's going to last for the next 100, 200 years. I don't think it will. I certainly don't want it to. Knock chips, knock processors. There will be an FPGA roughly a year from now. It takes more money to build an ASIC, an application-specific integrated circuit. It takes even more money than that to build something that's a whole general-purpose processor. But at a certain point, it becomes worth it, right? And you can analyze what that inflection point is by looking at crypto, right? When did they build the ASICs? There's a point at which it happens. And when did they start building ASICs for machine learning? There's an inflection point there, right? When did they start building ASICs for TCP? Because TCP is actually done mostly in hardware and high-performance machines. So you could do that with AIMS as well. So it's actually not just a knock processor that's interesting. Knock processor is very interesting, but then the next thing is an Arvo processor, where you take a relatively frozen version of the Arvo kernel and you tape it out as a circuit. You can't really do this with Linux, but you can do it with Arvo. Very reasonable. And you could even do it with other chunks of the system. And then you could even extend this further, and you could say you have an urbit machine. So there's a motherboard, so there's a CPU and the motherboard. And all that the motherboard implements is the urbit I/O channels, right? AIMS, Bane, Clay, Dill, Air, Iris, Con, Lick. But just those, that's it. Right? So you could have then a whole machine, right? And it's actually very useful as a communicator, right? But that whole machine, all it could do is run urbits. And so that you could actually, because urbit's doing one thing, you can have it do that one thing really well as a piece of hardware. That kind of constraint that goes all up and down the stack that urbit provides, that sort of full stack, vertically integrated constraint could enable hardware that's quite a bit more efficient, cheaper, more secure, certainly more secure. Similarly, transport agnostic networking. I need to be able to mail you a USB drive, you stick it into your urbit, and your urbit interprets that as a bunch of messages. It takes the ACKs, the acknowledgements, and writes them back into the drive. You mail it back to me, I plug it into my urbit, it does the acknowledgement. That should just work. Similarly, this should be able to go over mix nets, Tor, I2P. You should be able to put messages on chain, have somebody else read it off the chain. No reason you can't do this, especially with the networking system that we're building right now. And once we've done all of these things, then of course, we'll make anime real. And so I'm very excited for where this is going. I think we've seen a lot more progress in the last year towards some of these more like bombastic goals than I would have expected. So I'm going to end with a sort of call to action here. Ask not what your operating system can do for you. Ask what you can do for your operating system. And what you can do is you can go to the Urbit Improvement Proposals, the WIPs, and read through them, comment on them. Say what it is that you like, what it is that you don't like. Make issues to say what you would like to see a proposal for. Write your own proposal. And there's a good chance you can get grant funding from the UF to actually implement it. And we'll certainly talk to you about it. So this is rapidly becoming the center for core development, is this repo. So certainly check it out. There's a nice little listing of the 13 UIPs and what to do at the beginning. Some nice little pros. And we're going to be putting a lot of effort into this system. This is the main way that we're going to be communicating about what it is that we're doing, what we're about to do, what it is that we're considering or that we have considered and decided not to do, and why not. So please take a look at UIPs, read through them, write some of your own. Thank you.
Do we have any? Hello? Oh, perfect.
I have two related questions. The first is, why do you say we must do this in a year? Where does that must a year come from?
It's about how much money we have.
Oh.
No, it's more than that, actually. It's about how much money we have, and it's also roughly the timeline that the Urbit app companies need, I would say.
That the Urbit app companies need?
Yeah, like you work at an Urbit app company.
And the other question is, what in that sort of long grab bag of things, what frightens you the most about fitting in that year? Is there anything that jumps out?
That's a good question. I think it's the Gall agent suspension, because we don't have a spec for that yet. Most of these other things we either have a spec or we're very close to having a spec, but for that it's like we have an idea. We have a general sort of architectural philosophy, but that's like 2 or 3 steps from a spec.
Cool, thanks.
I also have 2 questions, one of which is related and one of which is sort of less so. We have this notion of Kelvin versioning where the version number counts down until it reaches 0 and then the software is considered finished. I noticed that you presented the idea of Urbit 1.0 and its successor being Urbit 2.0. What significance does this have, and is Kelvin versioning the wrong way to think about Urbit as an entire system, and we only version its subcomponents, or what is the reason behind that?
Okay, yeah. So I guess I wasn't that clear about it. So I like to think of Urbit as primarily a specification. All right, so it's a specification for machine code, language, operating system, network protocol, and an application programming environment for user space apps. Right, all that is a spec. So that spec is subject to Kelvin versioning, because what we're trying to do is freeze the spec to a place where it can be frozen forever. Right? As the first quote described, or alluded to at least, this has happened to a lot of other things in software. Right? If you look at JSON, there's not going to be a JSON 2.0. Not going to happen. Right? And this is true of a number of other things too. Right? You can find a bunch of stuff where it ain't changing. But nobody's tried to do this for a whole operating system or a whole sort of machine or a whole model of computation, not in any kind of concerted manner. I think Urbit is the first project to really try to standardize something in this particular way, right? So we're trying to say, okay, what is the part of computation that can be factored out and say, okay, we're going to freeze this part of it, and everything else will change around it, but this will be this island of stability that will just be there in perpetuity. So Kelvin versioning, in my opinion, is a very good way of trying to manage a project that's trying to get there. So the way I think of it is actually not necessarily that something gets exactly to Kelvin 0, and therefore it is frozen, and until it gets to Kelvin 0, it is not frozen. And a good example of this is knock, right? Like, knock is at version 4. We could change it a few more times, but we probably won't. The number tells you something, right? But it's a bit of a heuristic. The number tells you roughly how far you have to go, right? It tells you something like, okay, if you build an ASIC for knock, you'll only ever have to build 4 more, right? Because there will only ever be 4 more changes. But it also tells you, like, yeah, maybe it doesn't get that far. And different layers of the stack may kind of peter out and kind of end up resting. Maybe Hoon ends up at version 100 and never really goes past that. I actually think the further down they go, the better. And a lot of people have Kelvin anxiety, and they hear, like, oh, you only have 250 changes to make. Like, aren't you worried? It's like, no, I'm worried we have too many. I'm worried the numbers are too high, actually. Because then there's a little bit less of a signal that they give psychologically about, well, how much can people rely on it not changing? I think it'll be fine. I think we'll work it out. But the Kelvin versioning is an attempt to sort of lean into and recognize the fact that this kind of software will actually get standardized, de facto standardized, just by the market. So that's the spec, right? So the spec applies to kernel space. It doesn't apply to user space. There may be parts of user space that people want a Kelvin version. I can see that being useful for certain things. But everything underneath urbit, everything in the runtime, that's the part that needs to vary continuously, right? So you don't want a Kelvin version that, because somebody's always building a new piece of hardware. Somebody's always building, coming up with a new clever data structure for representing something, or right? Like, you can always optimize the implementation. So there's a separation of mechanism and policy here, right? The policy is that which is Kelvin versioned, that's in the spec for kernel space, and then the mechanism is whatever var is, right? Or whatever Aries is, or whatever that future chip is, that's or the future device that's a pure urbit implementation. So urbit 1.0, urbit 2.0, I'm just using that very I'm waving my hands, I'm saying, I'm using it to conjure up the image of, like, this is, it's production level. It's no longer an alpha or a beta, but it's not an official designation.
Okay, thanks. And my second question, which is basically unrelated to what you talked about, but I'm still curious, because you mentioned Rust a few times. I'm curious if you've had a look at Zig at all, and if you have any opinions on it.
Zig seems really cool. You'll have to ask Joe. Sorry, Joe. Resident Zig expert.
There's been a variety of talks this week that have touched on composability and databases, gripes about Clay, liking it, whatever. Where do you see that kind of in this stack in terms of ripping something out, putting something new in, having it happen in user space?
Yeah, so I think probably most if not all database systems in urbit should live in user space. The one exception I could think of to that would be if you want the kernel space to guarantee referential integrity for you across applications. That's, I think, the only reason that you would want any kind of database in kernel space. Because otherwise, it's up to the applications to sort of play nicely with each other and collaborate to ensure referential integrity across them. More or less. I mean, maybe there's some tricks that you could do in user space to ensure that, even without the kernel. But yeah, I don't know if that's I don't know if that'll ever be enough of a factor to try to push it into kernel space. And if we did, then the problem is that there are a lot of different database models, right? So there's the relational algebra that Jack is implementing. Was it Dodd? Who's the guy's name? Yeah, Dodd's relational COD's relational algebra, right? Which is like a fairly complete. My understanding is a kind of complete mathematical system. Then there's the thing that SQL implements, which is close to that, but not exactly that. There are categorical databases, there are EAVT databases, there are graph databases, right? So which one of those is fundamental that you could imagine putting in the kernel and Kelvin versioning? Are any of those fundamental enough? And my general hunch here is that none of them are fundamental enough, and that there's going to be a layer underneath the database that does live in kernel space that has to do with the scry namespace, right? And I think that each database table is likely to be something that's accessible through the scry namespace, and then joins on those tables will be sort of compound queries that read from multiple scribe paths. And I imagine that we've talked about a number of different indexing schemes there, some of which involve a sort of high-level query language like SQL, and some of which don't. So I think the database story in Urbit is yet to be really fleshed out. I'm happy that there are now 2 or 3 different versions of databases being built, right? So there's JAX, URQL. The Holium guys have Bedrock. There's another one from Ukbar. And what was it called? I think it's called Nectar, I think. Nectar, yeah. So there are now like a few different sort of takes on databases. And I hope there are more. And I also think that we should do more of sort of standardized data layout, probably for, I don't know, I'm not entirely sure, but like there's a vague idea that comes up a lot, and has been coming up a lot for a long time, which is basically like a trie with ordered values. So GraphStore was actually an instance of this, where it was a trie data structure where, with ordered values. So you have a sort of a recursive folder structure where you can do efficient range queries within that. And I think it's likely that Clay should probably use a data structure like this. Maybe the case that application data by default should use a structure like this, or use something that can easily be translated into and out of that. Maybe it's too constraining, but that's a sort of alternative way of thinking about data layout in Urbit that feels like it would lean in to the tree a little bit more, right? It's like a very natural kind of tree-based system in a way where SQL systems or EAVT systems like Datomic would be sort of mapping a different kind of logic, like a more constraint-based logic, I think, onto the tree, which might be the way to go. But I suspect that it'll end up eventually living on top of a lower layer that's more directly tree-oriented. I don't know, though. Yeah, okay, I love this question. So yeah, Urbit 3.0 runs in your neural interface. Yeah, and it's stored, its event log is replicated in a decentralized storage system. Yeah, it has all kinds of crazy multi-threading that we haven't even thought of. And the what else is Urbit 3.0? Who else has ideas for Urbit 3.0? Not crystals. Let's not get ahead of ourselves.
Network spirituality.
There you go.
So Aries is like 2 major parts, right? The 64-bit part that gets lots more storage for Urbit, but then also the novel approach to NOC interpretation based on what used to be subject knowledge analysis, but is now what? SAC, subject.
It's still subject knowledge.
Is it? Oh, they didn't do that?
It's close enough. What's the rest of the
Anyways, what's the status on that? Because that's sort of the
on the subject knowledge analysis?
Yeah, the more difficult part of the Aries.
Well, you'd have to ask either Edward or Logan, but my understanding is it's going quite well. Mm-hmm. Joe, do you know the latest status on it?
My understanding is it's complete. It's not proven in production. It's not proven at scale, but it's done.
Yeah, that's my understanding as well. Yeah, it's nice because that really is like probably the most risky of the 3 parts of that project.
What was the third?
Well, I like to think of that. There's the persistent memory arena, right? The PMA, and that's what stores all the data, right? So that's what stores your Arvo snapshot, basically. I think, and your working state. But then there's also the The knock interpreter, instead of having the loom and the road system, it has two stacks that grow toward each other, right? And so there's also that stack-based interpreter there, right? Or that's like the allocation, the noun allocation for the stack-based interpreter. I guess it's not just nouns. It's like, yeah. But anyway, yeah. There's the state of the execution, right? And there's the whole interpreter that knows how to use that. And then there's the third one is the optimization, yeah, which is the static analysis step.
So in terms of eliminating asynchronicity, what about GAL-managed request response? Or are threads already managed by GAL? I'm not
Threads
clear
are
on that.
sort of managed by GAL. In the very long list at the beginning of things that don't feel good about urbit, it's one of them was how threads are implemented, because they were implemented in user space first as a way to not sort of mess with the kernel and be able to experiment with them. But then they were made officially part of the kernel through the con vein, so that external processes could use a request response protocol with a stateful request response. Because the thought was that's easier to integrate into a bash script, basically. And so then that external system can call into con the vein, and then con runs those threads. And these are spider threads. They're not like operating system threads normally. I think we should rename them, actually, because they don't have anything to do with parallelism. It's really like a monadic input-output sequence. But it's like a script. And then, so that's a thread. But then the way that con actually executes a thread is that it asks GAL to run the spider agent, which is in user space. And then that runs it, and it sort of goes up and around. And it works. But I think that we're better off moving threads into the kernel at this point. I think that's going to be easier to enforce permissioning. And then once we have them in the kernel, then yeah, maybe that can be an official API for your application, is that you could expose some threads that other apps could call. That's a bit of a vague idea, but yeah, I don't know. I think there's something in there probably.
Yeah, so let's say you have a thought, right? Like something that...
Couldn't be me.
Yeah, right. Something that like maybe should be in kernel, but maybe shouldn't. But either way, like, or even is planned for core within like the next year and a half or so. But you don't want to necessarily enforce your opinion about this thing on other people, but you still want to experiment with this thing that could be useful in the kernel or core, later on. What kind of like thought process do you suggest people take to like think about like experimenting versus like working or kind of coordinating with core?
Yeah, it's a great question. So if someone who isn't you wants to do this, I was hearing that whole thing like an Arrowhead trip report. But yeah, no, it's a very good question. So I think I would say it depends on what you're trying to do. The first thing to do is come talk to us, and we can try to answer it on a case-by-case basis. But generally, it's usually better to experiment with things in user space. You can do a lot in user space, right? But it also can be very useful to experiment in kernel space. It's really easy to write a vein. People don't know this really, but like just to write a sort of blank vein. What, isn't it?
This is what core devs don't want you to know.
Yeah. One weird trick for improving the kernel is that, you can just write your own vein, and it's actually quite easy. And then, yes, you can experiment with that really easily. So that's much easier than modifying an existing vein, I will say that. That's tough, especially if the vein is GAL. But you can always write a new one called Schmall and run it right next to it.
If you see small anytime soon, I don't know who wrote it.
Yeah, I don't either.
Any other questions?
I think I was subtly called out as grug during the presentation.
No, we're all grug.
Okay, great. I'm gonna wear the grug hat for now at least. Okay. Here's my grug statement, and then I want you to convince me that Urbit 1.0 is actually going to get us there.
Okay.
I upload 10 movies to my urbit. Say they're 100 megabytes. I add 10 ships to some permissionless to download those movies. Those other ships, as soon as they get added, start downloading the videos automatically. And then those users from whatever edge device they have can watch the videos, like very basic social media application. So step one, I upload 10 movies to my urbit. What was
the last step there?
The last step is they've got these videos on their ship, and now they can watch the videos.
Yeah.
So step one, I can upload 10 videos to my urbit. What is like 1.0 doing to get us there for like that step?
Yeah. Okay, so you need a few things.
Yeah.
So you need areas, so that you can have 64 bits, you can store the videos. As for the actual upload, well, you could do it in Clay. It's not particularly nice to do at the moment, but you could. Or you could use a web upload form, and that should work as well as any web uploader works for large files. Which is to say, usually not very well, unfortunately. But if you have a good network connection, it'll be okay. And this is sort of a general problem. So that's, I think, what you need to get them in to your urbit. In order to expose them
if I fail, if I shut my computer down and there's a half uploaded video sitting in my new Ares loom, like, is that on the?
That wouldn't happen over HTTP. It'll either get the whole thing or not.
Okay.
Yeah. Same with Clay, actually. If you upload it through Clay, it'll either get it or not.
I add 10 ships to the permission list. Like, is that permissioning to read something from Clay in this case then?
So you could do it either through. So you could do this today with Clay if you wanted to. But if you did, then you wouldn't be able to use the remote scry protocol yet. In order to use the remote scry protocol, which is going to be the fastest way to deliver it to 10 people, we're going to need encrypted remote scry, which is scheduled for this year. And then, and I think that actually the way I would do this is, when you load it into your urbit, right? You load these 10 videos into your urbit, and then you go through and you add 10 people, right, who are allowed to see it. When you click that button, your app that's managing this actually sends a poke over AIMS to each of those 10 people saying, hey, here's a set of files at these paths. Go ahead and download them. And then the corresponding app on those other ships will hear the poke, acknowledge it, and then start to download.
Okay, so step 3, they start downloading the video. Let's assume at least some of them aren't directly peered with me already.
That's fine.
Okay.
They shouldn't have had to be peered with you. Peer discovery should just work.
How long does it take in Urbit 1.0 for these 10 ships to download these videos from me?
So the good news is it shouldn't take significantly longer than one ship downloading. The bad news is it depends on how fast we get the network bandwidth to go.
And that's slated for 1.0?
Yeah, so some network improvements, like network bandwidth improvements, are slated for 1.0. I don't have a great sense of exactly how far we'll get with that.
What's the, like, if we did this today, let's just pretend we had the storage.
If you did it today...
100 megabyte videos.
Yeah, okay, so what's the current bandwidth max? It's like 200 kilobytes per second? So 5 seconds per megabyte. So 500 seconds for 100 megabytes. So 500 seconds is some number of minutes. 9 minutes. 8 minutes. So yeah, it would take about 8 minutes. And yeah, but the nice thing there is if you can use remote scry, if we have encrypted remote scry, then it'll take 8 minutes and they'll all get it, even though that's the max that one's getting. So yeah, I mean, we want that to be quite a bit faster. And I don't have a great, do you have a? Yeah, we don't have estimates, but we should be able to get significantly faster than that. We know what the bottlenecks are roughly. So their bottlenecks are, they can be disk writes. The congestion control algorithm isn't necessarily all that well tuned. And the third one is that there's Arvo processing overhead. So Arvo does an actual event for each packet. so for each kilobyte. And so if we can, oh, and for right now for FreeNAND, there's authentication overhead from signing every packet, which is ridiculous. So we can get the authentication overhead down to pretty much minimal for large data. Even in this first version, that'll be minimal. Congestion control, we're not going to touch for now, but we might do some incremental tuning of it over the next incoming months. And the big one is going to be figuring out how to basically batch packet delivery some way, so that the Arvo, there's Arvo's outer loop, just like running an Arvo event, is about 2 milliseconds. And so that'll cap you at 500 events per second, right? And so that'll cap you at 500 packets per second, which is then 500 kilobytes per second. So we certainly want to go above that. And so what that means is that you have to batch the packets so that you're delivering, say, 10 or 100 packets into Arvo at a time. And then you only pay that 2 milliseconds for every 100 packets.
Got it. Okay. And then the final step. I've got my video. I've gotten my Grug video, and I want to watch it now.
Yeah.
How does 1.0 get us there? That's like streaming from my Urbit, right? So
yeah.
Do the users then need to like re-download these videos to their devices to actually watch them?
So that's a good question, and we might need to build something to allow a partial file download.
You need a registries over HTTP to
yeah.
serve it for streaming video.
Yeah, so that's an interface. So that's yeah, but we would need to build that. So that's I think that's a project in similar level of complexity to Scry over HTTP, which you're doing now. So like roughly a month of from like inception to deployment. Yeah. Does that answer your question? Cool.
Okay, maybe just one more question.
Oh yeah, kind of a small question, but the packet signing stuff and kind of like the merging of FNA and it's like when do you have like a rough timeline for that?
We want it done by assembly and then deployed by the end of the year.
Awesome. Thanks.
Okay, and with that, let's give Ted a round of applause, everybody.
Okay, thanks everyone. There will be YouTube videos of these, so there will reference. There will be some post-production done, so it will be up a couple days, maybe a week at max. So yeah, please enjoy. There are refreshments, and for those of you who want hats, please enjoy refreshments first, and then I'll grab you, and then we'll go and get hats. All right.